Good afternoon, everyone.
I was trying to unmute Andrew. Good afternoon to you. And then other two students have come to class and don't say audio to me at all, but never mind. As per usual, I'm driving. I'm still in commute. I couldn't say that. I'm still in commute. One of my charitable works is to assist in MC in different programs, and I was just called to MC. Well, not just called, but I MC'd a graduation just now, and actually on my way home. So I'm actually in commute, guys. So I'm going to beg you a little bit of time. Forgive me, but I can have conversations with you. But let me see how far this I'll get before 5:15. All right. So just go on to some looking over on the documents that I sent. By the way, Susu sent you a document recently. No, not Sue. Sorry, I sent you all the document recently, right? Which class is this? No, sorry, this is not. Which class is this? This is Foundation 3.
Yes, foundation.
Did I send, right, right. So I keep mixing up with this class with my applied math class. Did I send you the notes from the last class? Please say yes, I did. No?
Not so certain, but let me take a look.
Yeah, please. I keep mixing up myself. All right. But I'm not even near the system now because, as I said before, I'm in commute. All right. Let's just see how far I can get to by 5:15. All right, and keep you posted.
All right, no problem.
Yeah, man. I did send the stuff. Remember I'd sent you the handout with the rules to calculate the length of a line and the midpoint of a line. I gave you that document. I think it says something about unit 4, something like that. It was a typed document. And then I gave you some questions on it. I had placed it in the chat actually. Well, let me know if you find it. Can look at them and let me know if you find it, please.
Good evening, everybody.
Hi, Palumi.
Good evening, everyone.
Hello.
Good evening.
Hello.
Evening. Good evening, everyone. Good evening.
Good evening.
All right, guys. With you now, I am trying to connect with my. Oh no, that's not what I do. I'm trying to boot up the system, so make a few more minutes, please. But I'm home now. Good evening to those who just joined or joined not too long ago. I'm recognizing the numbers. The numbers. Well, let me not say anything else until we into the session because I'm only seeing 36 of you here. Want to skim on. Welcome back, Freaka. Missed you last week, and Avril, we missed you last week, man. Welcome.
I know, sir. I miss you guys too, but I was updated though.
Nice. I'm just checking my register while this thing comes up. Is anybody in the class today that is here for the first time? All right.
Sir, they not for the first time, but second time.
Mm-hmm. All right, you know my problem already, guys. Yeah. All right. All right. So Andrew, you're supposed to check to see if you received the handout that I had sent. You find it? You see it?
Yes, I think yes, big boss. I see.
Right.
I see
Good. It's just that you were talking to me, and then if I don't know you've been silent, so I was wondering. All right. So again, thanks for facilitating me just coming in to officially begin. I For those of you who just came in, I emceed the graduation today, and it started 1 hour late. I only consented to it because it was supposed to start at 12 o'clock. I was there before 12, and not until about 5 minutes to 1 o'clock they started. So I knew I was going to be in some problems. So don't worry about it. You'll have more than enough time or opportunities with me to make up this time. I'm just going to ask you to just give me your undivided no as I try to bring up this document.
Afternoon, sir.
Afternoon to you, Papa.
Yes, sir, the machine up here now?
You know, it is not yet up, but the good thing about it is part of my delay, if I were to be honest, part of my delay is en route to my yard from the graduation. How do I copy this thing now? The other system remain was sent this morning. So when I reach one place, I say, all right, keep in touch with me, guys. When I reach one place and say, all right, I'm going to collect this. It is on my way to go home. It's not going to take up anything. When we reach at the place and say, yo, I want number you there, because me the Pine Avenue, you know. Oh, we're down Studio One Boulevard. I'm a pause. I'm say, seriously? I mean, no waste all my time drive come here and then I forgot drive go back. But I was reminded that I am at their mercy. They never have to carry come down for me. So we just give them a mouth and take my time and drive, you know, and that's why I'm so late. But yes, so I have the tablet with me now. I have not even opened back the box yet to look at it. I don't want to do it while I'm in class. I want to just get myself focused so I don't make the same error. But I should be up. I was hoping to get it earlier so I could have set it up and ready for you guys. But next week should be a better week for me in terms of the teaching and learning.
No problem.
Yeah,
Just
big
want
up
to know
yourself.
say you get it back and thing.
Yeah, man. Yeah, man. All right. Foundation 3. I'm actually trying to. What did I send this document? But I sent a document. Oh, it's coordinate geometry. Let's open both of them. All right, so this looks like applied. No, this is not. Oh. And into paragraph and take off this thing. All right, hold on. All right, so I don't know how this formatting tab came up, so I just removed it a while ago. All right, so the onto coordinate. Let me see if this thing can scroll. Every day something else is missing from this computer. All right, so we did some of those. We did all of those already. I just want to spend a few minutes on speaking about question. Speaking about this page. And when I complete that conversation, for sure, we're moving on into something new. Moving on to something new. Lord, should I do that with them now? Or do that afterwards? You know what? I'm gonna do that activity. Yes, let me do that activity with you. So I can get.
Sir, I don't know if it's my end, but you sound muffled in and out.
Anybody else hearing me?
I'm hearing better.
Are you hearing better now?
We're hearing, but sometimes it's like you're talking to yourself.
Well, that's
You know, that
exactly,
low-
Andrew,
Yeah.
say less, because that's exactly what I was doing to myself a while ago.
All
I'm
right.
here saying, I'm finished with this topic. Should I move on to that topic or should I move on to the other topic? So I was actually contemplating. So I wasn't really teaching at that point. So I was really talking to my inside voice and answering myself. All right. So I think I may do that. It's a nice little activity, and at least it's a big chunk of the syllabus, and I can get that out of the way. And then we can do the other little part, the other little graph parts afterwards. All right, no problem. All right, so for perpendicular lines, the product of their gradients equals -1. You have to remember that. For perpendicular lines, the product of their gradients equals -1. Right? So what it is that we're doing is finding the negative reciprocal of the other. That's just another way of saying it. We're finding the negative reciprocal of the other. It's just another way of saying it. Always remember too that parallel lines have the same gradient. Put it this way. I'm sure not because you are evening students and we do classes online. I'm sure you all know where to find Excelsior Community College. You know that Excelsior Community College, the location is of a dual carriageway. Dual carriage because it carries two lanes, two up traffic and a down traffic. So called a dual carriage. And 2 lanes each on either side. Hear me out. If I calculate the gradient of one side of the dual carriage, I calculate the gradient of one side of the dual carriage. It is going to be the exact gradient as the other side of the dual carriage. Why? Because the dual carriage is parallel. Can you see that? Can you understand that?
Yes, sir.
Yes, sir.
Yeah, man. So we say that parallel lines, once the lines are parallel, they have the same gradient. So I can ask you to calculate the equation of one side of the dual carriageway, but I will give you the gradient of the opposite side. You will then have to make the statement, parallel lines have the same gradient. Once you make that same, so therefore the gradient of that one equals the gradient of this one. That is your 1 mark. If I say to you, Deanery Road is perpendicular to Mountain View Avenue, but I gave you the gradient of one of the roads, it simply means that you have to find the negative reciprocal of that gradient in order to get the gradient of the other road, because one is perpendicular to the next. So I believe if you're going to give any questions in the exam, they will give you a full question, like for argument's sake, points A and B falls on the same line, calculate the gradient of AB. Calculate the equation of AB. And they will say to you that a line cutting AB passes through the point, and they give you another point and say that it is perpendicular. Calculate the equation of the perpendicular line. Boom. One question that's enough for about 10 marks. One easy 10-mark question that on what it is that we're doing here. So let me just run these two examples, and then I'm going to project something. I'm going to drop it in the chat for you. And how do I do it? Yeah, I'm going to drop it in the chat, and then we're going to have a good half an hour conversation. And then after that half an hour conversation, I'm going to give you one or two little exercises to do. There's another easy aspect of it, but I think I want to, if I do this one, I can get you a whole lot more. And based on the fact that we miss out a good chunk of almost an hour, I can make up some time, some grounds on this. So I'm going to do that one next. All right. So to calculate the equation of a straight line, as I told you last week, the week before, and I'm reminding you today, I would need two things. I need one, a point, and two, a gradient. So I need a point and a gradient in order to calculate the equation of a straight line. So let me just run through with you 2, 3, 4 examples 2, 3, 4. Even though the solutions are there, but nonetheless. Well, the answers are there, the solution is not there. It says calculate the equation of the line perpendicular to y equals 2x plus 5. And it passes through the point 1, -2. All right. It says to calculate the equation of the perpendicular line. So there are two things coming out of that. Calculate the equation. All right. To calculate the equation, I need two things. One, a point. Two, a gradient. To calculate the equation, I need two things, a point and a gradient. Agreed on that?
Yes, sir.
Totally.
Yes, sir.
Yes, sir.
Yeah, man, good. But now it uses a line, something it said the line is perpendicular to that line, that equation. So for perpendicular lines, the product of their gradients equals -1. So I have to find the gradient of this and then reciprocate it. What is the gradient from this equation? Y equals 2x plus 5. What's the gradient?
2, sir.
2. Very good, Romain. Everybody so it is 2. Y equals, is it in the form y equals mx plus c? This is what we did in the first day of
sir,
class,
okay.
you know. Right.
Yes, yes.
Right. So the gradient there is going to be 2. M is 2. But if we use that gradient, is that the perpendicular gradient or the parallel gradient?
Parallel.
It would be the parallel gradient, right? Because
yeah.
parallel lines have the same gradient. And I really hope some of you who are multitasking come close, because these are things that we need to pick up, so it is that we can get this stuff out of the way. So parallel lines have the same gradient. Now the lines that are perpendicular, we need to reciprocate the gradient. So having found the gradient to be 2, we are going to find the negative reciprocal. See it right here, so? Another way of saying it is to find the negative reciprocal of the other gradient. So we have a gradient 2. We need to find the negative reciprocal of 2. To reciprocate, we're going to flip it. 2, a whole number, is the same thing as 2 over 1. When we flip it, when we flip 2 over 1, what do we get?
1 over 2.
1 over 2, a half. 1 over 2, a half. Yeah, man, right. And then now we're going to use a negative reciprocal. If it is a positive number, it becomes a negative number. If it is a negative number, it becomes a positive number. What number is right here, so positive or negative?
Positive.
So therefore it becomes a?
Negative.
And that's why the gradient m is -1/2. Look at how I get the -1/2 there, so. That's why the gradient there, so is -1/2. Now, guess what? You get 1 mark for that, you know. You get 1 mark just for that. And you know, start the calculation, because all of that can be in your head space. All of that can be done into your headspace. So we need to find the negative reciprocal of the gradient in order to find the perpendicular gradient. Parallel lines have the same gradient. If the lines were parallel, they would have had the same gradient. If the lines were parallel, they would have had the same gradient. But because the lines are not parallel and it's perpendicular, it means that the product of their gradients is going to be equal to -1. The product of their gradients is going to be equal to -1. So M is going to be equal to -1/2. Everybody see that now and agree with it?
Yes, sir.
Good job. Oopsie daisy, you know, so the Bembe we just shut off. You know, so me start class and don't plug in Bembe, and Bembe is no longer a laptop, it's a desktop. Hold on there, hold on there, hold on there. Bembe would have just shut off without any warning. Right? Bembe is fine now. Okay, great. Now it is asking us to calculate the equation. I need two things. I need a point and a gradient. Am I given a point? Am I
Yes,
given
sir.
a point? What's the point?
5, y, the intercept.
No, what's the point?
Oh, one and
One and -2.
-2. I
Very
didn't
good.
even realize that was down there.
Right. 1, -2. And what's the gradient now?
-1/2.
Very good job.
Oh.
Excellent. Excellent.
Sir, may I
-1/2.
get confused?
Why comes?
No,
Where
no,
you eat for
no.
lunch today?
Sir.
Or you never
Some
eat lunch
fruits.
before?
Sorry, I'm kind of confused.
What kind of
Sir,
get
go back
little
over
bit
that, please.
Go back over what? I was just asking, what's the point? The point is that. And what's the gradient? The gradient is that.
Oh,
So
so
to
we're
calculate
following the steps up here from at the top here.
right, right.
Okay. All right.
So to calculate the equation of a line, I need two things, a point and a gradient. I have the point given, but them tell me say the gradient is perpendicular to this one. Perpendicular gradient, the product of their gradients equals to -1. That's one way of saying it, or we can find the negative reciprocal of the other, which is another way of saying it, but the same results. So we already calculate the gradient to be equal to -1/2. So to calculate the equation of a line now, like we did before, we're going to say y minus y1 over x so this now. So this thing unknown in class on Wednesday say, Jesus Father. Oh, finally. Over x minus x1, and that is equal to m, the gradient. Now, it's y minus y1, y minus -2. Can you all see that? Over x minus 1 is equal to -1/2. Can you see that, guys? Why is it y minus -2?
That's the negative.
Point is -2, sir.
Very good. The point is -2. Excellent. And then it's y minus the y value, right? Okay, good job. So that now becomes y plus 2 over x minus 1 is equal to negative 1 over 2. And I'm going to say this one more time. I said it last class. I'm going to beg you to always remember that you're going to keep the negative sign in one position. Don't put it in two. Normally, when I do the calculation, I just put it in the numerator so I can just get it over and done with. So I have nothing to worry about. All right? Look at this now. Becomes 2 times y plus 2 is equal to negative 1 times x minus 1. 2y plus 4 is equal to negative x plus 1. And I multiply two negative numbers, I get a positive number. So that negative 1 outside multiplied by the negative 1 in the parentheses gives me a positive 1. And the negative 1 times a positive x gives me a negative x. To put it in the form y equals mx plus c, I'm taking everything away from that side. And remember, how I show you, you need to subtract 4 to cancel those. So you have to subtract 4 from that side. And that's how we get this. So now we're going to have 2y is equal to negative x minus 3 when dividing each term by 2. Y is equal to negative a half x minus 3 over 2. And that's the answer. And you can confirm my answer right here. Any questions?
Yeah, yes, sir, Sean. You lead me from the arrow. From you draw the arrow,
Mm-hmm.
the y plus 2 equal the negative a half with the x under the sum. If you couldn't just start back from there, let me see if I couldn't catch your rhythm from this again.
So when I have two fractions separated by an equal sign, I cross multiply. All right? So look at what is happening. I'm cross multiplying. So this 2 is when they multiply this x plus 2. Teacher, this y plus 2. So this 2 is multiplying the y plus 2. And this negative 1 is when they multiply the x minus 1. Teacher, negative 1 multiplying the x minus 1. You see that?
Yes, yes.
One more time. So I'm cross multiplying. I have two fractions separated by an equal sign. Cross multiplying. This 2 is going to multiply everything up here. So it becomes 2 times y plus 2. 2 times y plus 2. This negative 1 is multiplying this x minus 1.
All right, cool. Catch that part now. So just go down the rest now, please.
2 times y is
2y.
And 2 times 2 is
4.
good. And it's equals to negative 1 times x is
X.
no, it's a negative x.
Negative x.
And negative 1 times a negative 1 is a
Positive 1.
good job. Now I need to isolate this positive 4. I don't want it on this side. So in order to get rid of it, I have to subtract 4 from both sides. Stop truth.
Okay.
So that's why I have the minus 4 there and the minus 4 here. Those cancel. So all I'm left with on this side is just 2y. Can you see that?
Yes, I'm seeing that.
And then I have the minus x plus 1 minus 4. And then what is 1 minus 4?
Negative 3.
See it right here, so. And then this minus x is right here, so. And this 2y is right here, so. And then I'm going to divide through by 2. So why did you divide through by 2? Because I don't want 2y, I want y. So any number in front of y is that number I'm going to divide by. So I'm dividing both sides by 2. I'm dividing throughout the equation by 2. So that's why I have 2 in the denominator for all of them. And those two cancel. So I'm going to have this y right here. So negative x over 2 is the same thing as a half x, negative a half x, negative a half over times x, or same thing, negative a half x, minus 3 over 2. Boom.
All right. Thank you very much, sir.
No problem. All right, I want you to do me a favor. All of them something here in green and red should be here. I guess it's based on how I was writing last week and the system was going on. Afraid to touch the eraser because I touched the eraser on Wednesday and it just messed up my stuff. I'm gonna see how else I can erase this stuff. But while I try to erase it, do me a favor. Read the other question and try and attempt those questions for me, please. Not those. Attempt that question for me, please. Attempt question number 3 for me.
Which question
I'm
is
trying
that,
to.
sir?
Huh?
Good afternoon. Which question is that, sir?
Oh, sorry. Thank you, sir, for coming. I recognize that. Question 3. All right. So let me just pause right here now, guys. I was waiting for him rather to come in. So that's Mr. Nicholson. Remember last class we had an agreement that we'll have the pair of us come in instead of us. Yes, the class will be split, but it will be split but kept together still. So I will go through portions of the lesson, and Sir Nicholson will go through the other portions of the lesson. So he just asked, what question is that? So you look Mr. Nicholson in the chat and make him feel like he's welcome, because him is a good maths teacher. Somebody has been with us for quite a while. I need help. There is no way I can carry 76 of you guys that are on paper. So I had that conversation with you before. So we are just wrapping up the unit 1. So we are finishing off unit 1, Sir Nicholson, to move into. I thought of doing. Well, you know that I had a difficulty trying to get home from the graduation, so got in a little
Yes,
late.
sir.
So I'm trying to. Right. So I'm trying to see how best I can catch up on some time. So I'm going to be moving into some other aspect of the coordinate geometry. So I'm going to share a worksheet and then just have a discussion and do 1 or 2 questions. Hopefully that will take us up to the end of the class. All right. So we're looking at question 3. Forgive me. I'm trying to delete. I'm trying to delete these things that I have here because it's don't wait for me, guys. Go ahead and do and attempt the question for me, please. Go ahead and go ahead and attempt question 3. Boys,
thanks for the welcome, guys.
Yeah, man. Big up yourself, sir.
Welcome, sir.
Thank
Our
you,
apologies. We are a bit stressed.
Don't tell a lie for me, you know.
Sorry about that, sir. Welcome.
Thank
all
you.
right.
Thank you all.
What I'm trying to do, guys, is just to see if I can just delete this so I can have something to write on. As in your.
All right.
Okay. Oh no, undo.
Let me see what I can.
All right, so number three is what we're looking at. Remember, for perpendicular lines, the product of their gradients equals -1. Or you can find the negative reciprocal of the other one. For parallel lines have the same gradient. So you can't ignore the instruction given and just do your thing. If it says perpendicular, you have to go and find the perpendicular stuff. If it says parallel, you know, say just find the gradient, you just extract the gradient from the equation given, and you know it's the same gradient. But if not, you have to work it and twerk it. All right, so this one is a little easier than the one we did before because the gradient here is parallel.
Sir.
Yes, please.
I was following, not sure how I missed that. Looking at the question about where the arrow is pointing to the second line right there. How did you get the -4?
Remember, we're trying to isolate a +4. So remember, in order to isolate it, we do the opposites. So because we have a +4 there, in order to get rid of that, I have to subtract 4 from both sides. So if you look at one side of the equation, you see a -4, and that's why I put it in different colors. So look for the same orange color on both sides, and you see
Sir,
can balance it. Go ahead.
I get multiplying, subtracting it from both sides, but where does the 4 come from? Because it's a perpendicular or something.
No, because I want only 2y alone to be on this side,
Right.
and I have a positive 4 here, so I need to get rid of this positive 4. Now, you see,
Mm-hmm.
because we come from country, we're not going to talk about we're carrying over to the equal sign. That don't make no sense.
Okay.
So the method that we use is we're finding the
okay.
additive inverse. Yeah.
Okay,
You see,
okay.
so me said that a while ago, and you recognize me I talk about?
Sir, hold on. I was just wondering why would he put the negative 4 there when clearly when the multipliers are positive 4? Okay.
Yeah.
What we're doing there.
All right. So I give you 3 more minutes to finish off that one. Now, if I had a good computer up, this done long time,
Mhm.
So.
Point is to -2. So we have x minus 2
Want to finish?
I am, sir.
Yeah, forward
You
for
got,
the one.
you've got the same answer as I have. My answer is there already, it's just that the workout not there.
Yes,
got the
sir.
same
I
formula?
got that, sir. I got y equal 4x over 3 minus 14 over 3.
Good job, my love. Good job. All right. So I can guarantee if it's the same thing for question 4, what I'm doing here, I won't be doing it here. So this thing is so tedious.
Sir, me still lost. Me literally lost.
Also,
Me no know. I think I have something against this math thing here, so I just can never get it after a while. Like I might start out okay, but then I start getting confused. Because right now, me no know what to mess up.
Where at what point are you at
Alright.
what point are you stuck?
Alright, so because parallel lines have the same gradient. What I had done, I was using the y minus y1 divided by x minus x1 equal
wait.
m.
Right. Okay.
And then
Okay.
I said y
You are
minus minus 2
you're on
divided
the
by.
right track. You're
But Mr.
you're on the right track. But did you
But
find the gradient?
I not do that.
You
Equal
don't you didn't
4x.
did you find the gradient first?
No, I just write find the gradient. So the gradient was with the 4x.
No, follow me. Find the
No.
gradient
You have
first.
to
Use the 3y minus 4x equals 7. Use that as the y equal mx plus c.
Hold on there. So
Right.
may I calculate
Yeah.
out that fraction there?
No,
Yes,
listen,
you have to
follow
make
me.
sure
Right the
you have to
y
make sure that the equation is in the form
good
y,
equal
so that's
mx plus
1y equals mx plus c, where m is the gradient. So you need to express 3y minus 4x equals 7 in the form y equals mx plus c. All right, so you're gonna get what? 3y,
I know. All right.
3y
So I'm gonna
minus
try and
4x
then we'll come
equals
back.
7. Huh?
I'm going to try and then I come back if I
Okay,
get
so
lost
start at
again.
that point. Start at 3y minus 4x equals 7 and express that with only y equals the gradient times x plus
Y equals 7
whatever. All right?
plus 4.
But your gradient is supposed to be 4/3. So if you check and see if you get that.
All right, my mama go and work again.
Oh, okay. All right. Let me check the chat. Ooh. Where's my screen? Sorry, still there?
Excuse me. So you say I must get 4x over 3, take away 7 over 3, something like that, you say?
No. Oh, hold on a sec.
Oh, me do.
You get, all right. Just one sec. Let me just bring back this. Let me just bring back this thing on my screen. Okay, so you're starting with 3y minus 4x equals 7. You only want y, you want y on one side, only y on one side, yes?
Yes.
So to get rid of the negative 4x, what do you have to do? You have to add
Oh,
add
let's skip
4x
out
to
that
that side.
procedure.
And
No,
because
no.
it's equal, it has to be balanced. So if you add something to the left-hand side, you have to add it to the right-hand side, yeah? To keep it balanced. It's like a seesaw. Once
Yeah.
it's equal, it has to be balanced. Your scales have to be balanced. So you add 4x to the left-hand side, and then you add 4x to the right-hand side. Yes?
Yes, sir.
So what you get when you do that?
No, I didn't do that. I
Okay.
didn't do that step.
Do that step, and then into the next step. Tell me what you get for the next step.
I equal 7. So I got equal 7 minus.
Wait a minute. 3y is equal to
So we're not gonna, because they say I must add. So when I add it, you're going to
add. You
cancel
add.
out.
So it's plus. Right? So you're adding 4x to the left-hand side to cancel it to the additive inverse. Yes? And you're adding the same thing to the right-hand side.
Right. So when I add 4x, oh, plus instead of minus. So when I had it, it cancel out the negative 4x and then 3. So it's going to be now the equation going to be 3y equals 7 plus 4.
7 plus 4.
Mm-hmm.
7 plus
And then
4.
I'm going to
7 plus 4 what?
4x.
4x.
Sorry. And then I'm going to divide here to get the y by itself by the coefficient. The 3 divide the 7 by 3. Divide the 4x by 3.
By
The 3
3.
cancel 3. So I'm going to have y equal 7, going to be 7 over 3 plus 4x over 3. Which going to
4
be
over.
y.
Yes.
Y going to be 7. No. Y going to be negative 4.
Well, no,
because
no, 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 no. Wait.
Follow me,
Wait.
stop. You find
Stop.
it already. Look at it. Your
Look
equation
at
then
it.
now.
Look at
Y
the
equal
equation.
mx plus c.
4x, Jesus Christ.
Follow me, just
Hold on,
Tell
let me
remember
no
take
one
a
you have
deep
seen.
breath.
Tell no one you have seen him, Salome. You can't do that. You
Follow
should
me, you
not
Let me
reveal
find
take
it
that.
a deep
already.
breath.
Look at
So
it.
Alfred,
the 4x,
Alfred,
no, they are the
Yes,
end.
sir.
Me want
she
get
get
it in the
nervous.
middle.
I you come to class today.
Salome,
I swear
one
she get
second.
nervous.
1 second. What do you have?
Me,
I
sir.
have y equals 7 over 3 plus 4x over 3. So I was
All
going
right.
to move it.
Hold on 1 second. 1 second. 1 second. So if you have 7 over 3 plus 4x over 3.
Yes.
All right. Let's say on a side, let's say you have 5 plus 4. Is that the same as 4 plus 5?
If I have 5 plus 4.
Is it the same as 4 plus 5?
Yeah.
Exactly. So you have two positive numbers. So either one can come first, yes?
Okay.
So now what you're going to do is put the variable one first, the one with the x. So
That is what I was doing, but through I'm moving it, I now
see.
start to add a minus sign, but that wasn't
When
necessary.
is the addition sign, the numbers can come in any order, okay?
Yes, sir.
All right?
Okay, sir.
Good. So tell me what you have now.
Y equal 4x over 3 plus 7 over 3.
Great. So what's the gradient?
4x over 3.
What is the gradient?
The 4x over 3.
What's the
Look again.
gradient?
The gradient.
4 over 3.
So the 4x up another 4x over 3.
No, the gradient
X is not a
the
gradient. Follow me. Remember now?
y equals.
Remember. I do
The
too much
number
math
without the
something,
X.
man.
Okay. See
Oh,
the equation below that equation that you have there, y equals 4 over 3x plus 7 over 3. Below that equation, I want you to write y equals m plus c.
Oh, God.
Yes?
Paloma, what time to you tonight? You were getting something before, Paloma.
Sir, I tell you, I think you need to get the lady to come back again, because it look like the effect are wear off, because I think I start seeing too much numbers.
Remember the last time we spoke about it, and y'all make was it Africa or Albury? I make one of them. I get short when I say, "Member no man, sure, you know member no."
Sir,
Yeah,
sir,
sure.
that
She
is,
hurt my
but that is
feelings,
a good.
sir.
Yeah,
She hurt
yeah.
my feelings. Sure, because she knows y
Yes, yeah,
equal
I got
mx
it.
plus c. And she keep on a call the wrong thing. The m is the gradient.
What
Follow
is
me. I call beyond for you.
All right.
So.
Not the X, not the X, not the X, the M.
Rough her up again for me, Albury.
So the 4 over
is right. So
Right.
remember,
There
the
you go.
coefficient of x is the
The
gradient. You know what Alfred
gradient.
said?
Yes,
The
sir.
coefficient. So if you tell me 4/3x again, you have to go buy the whole of it curry lobster next time. They say it.
Eh?
Yeah, man. It's
Sorry,
not
I must
hard, man. Just remember
understand.
y equals mx plus c. The coefficient of x is the gradient.
Sir,
Boom.
just drop something. Let me practice here. And let me see
All
if
right.
they can stick.
Big up yourself. Is that a parallel gradient or a perpendicular gradient?
It's a parallel gradient because so both lines would have the same gradient.
So that means parallel lines are the same gradient. What if it was perpendicular? What you say?
So we find the negative inverse.
Okay, good
So
job.
that
See, you
means
know
that
this
would have.
something. You know
Me
this something
just
else when
remember because me just read it, but by next week, me swear.
Alfred, rough her up again for me. That's why you
Sir,
can't miss class.
Sir, follow me. All right, here,
So we
follow
have
me
this one.
exactly what she's supposed to do.
So we have this one. All right. So we have this one class. So if it's a parallel gradient, what's a gradient? What's the gradient of the parallel line? Everybody, anybody?
4/3, sir.
Right. And if it's a perpendicular line, what's the gradient?
For the same one, sir, or for
This
any
thing,
one?
yes.
-3/4.
Big up yourself. Who says so? Who says so?
Follow me, sir. Follow me.
But that the
Follow me.
inverse.
Follow me.
The
Follow me.
inverse mean you
Follow me.
flip it, right?
Follow me. Follow me. I don't want to hear nothing from you. You play with
Sir,
me.
and that the thing is, make me get it now, but it's not staying. I don't know what I need to do. It's like,
Follow me.
hold on.
You are playing with Mr. Nichols
Okay.
and myself. Look how quick you come out of the battery that follow me. Me you go have things
Sir,
out
me
to do. But very
understand
good.
that. Me not think you understand fully what I'm going with me.
But
Just
very
not
good though.
sticking. I need some Velcro tape.
Follow me, I understand.
Andrew, oh, you stay. You understand? You said that, Andrew, you getting it?
Yeah, man. So you know if me not get it, me have a tag.
Me
You
know
know
that.
that. You
Me know
have
you're
to
gonna make
ask.
a pure noise. Me know you're gonna make a pure
Yeah,
noise if you
man.
don't get it.
Yeah.
Yeah.
Right.
All right.
But me follow on and me go and log on.
Yeah, man. Same here. So, is there any student in the class here for the first time tonight? Because I'm seeing some names that I can't recall seeing. Is there anyone in the class that is here for the first time? Okay. I'm gonna go through that list now because we need to prepare separate lists. Though we are going to be joining, but we need to prepare a separate list. And those people who don't come at all but are registered, I am not going to be even putting it down on the list. We give it back your money and the foundations we are not at another time. All right. So there are 43 of you because no lie. 42 of you. I am there twice. Shamar is there twice. Mr. Nicholson. So that's 2, 3, 4 from that. So there are 42 of you here. I'm not seeing the 76 that have selected the course. But anyhow, all right, all right, Paloma, since you're having a difficulty, can we continue so we can finish off this one, please?
Yes, sir, you can continue.
No, it's you can continue. Talk to me. What you right? Oh, me must continue.
Oh,
Come on.
so all right, the parallel gradient is 4/3 and the perpendicular. Well, I didn't need to find but I just write it that it's
Great.
Right.
-3/4.
So now you're moving on to finding the equation.
So what do I write for the equation? Tell
y
me.
minus y1 divided by x minus x1 equal m.
Good. And tell me what is it now? You're
so
correct.
You're going to have y minus -2 divided by x minus 2 divided by 2 minus 2, yeah, equal which is the 4/3.
Okay, what next?
Then we're going to then we're going to solve.
No, hello, cute. Tell me what to do.
Okay. So the y is going to be negative minus. No,
Well,
no. Hold on. Wait there. I want to go on here.
Look on the question in front of you. Stop tell sir about -2. Y minus -2 is what, follow me?
I don't know what y is.
Negative and negative give you what, Paloma?
Positive 2.
Okay. So it becomes y plus 2.
Y plus 2 divided by. You're my teacher friend.
I love it. No, let me tell you. If you see my face, you're supposed to see how white the white smell on it. I love it. And the rest of you, I want you to listen. All right.
So,
come up. Yeah, over.
So y plus 2 divided by 2. What's that? So 2 minus 2 minus 2. So 2 plus 2.
Paloma, we want to the x minus 2. Why you not putting a part there?
So divide. So it will become now 2 plus 2.
No, Paloma.
So what me I gonna get? No, me not look
That
here.
would remain x
April,
plus
please
2,
finish
x
it.
divide x
So me
minus
I
2.
get.
Paloma, I am
No,
not finishing it.
Avery, you're not finishing it. Paloma, come because Avery is telling you, look at the something and she want you to look on it and talk to me. So
Because
Avery not
x
finishing
a
it.
positive 2. All right, sorry. So it's x minus 2. Sorry.
Thank you, please.
Very good.
Hello.
Sorry.
You know what lap say? Oh, we know. Next.
Sir,
Don't
I'm
call
going
to
to
me.
send a nice picture. Don't worry yourself.
Come, what's next?
No, on a picture.
All right.
No.
Sir, me stop. Make somebody. My brain a
No.
bubble.
No.
Come,
All
Paloma.
right, so
Don't do
we're
this to
going
me.
to have.
Anybody, keep going. Think, man. What you
Equal
supposed to put there?
4/3. All right, so once you have a fraction separated by a fraction, we cross multiply by an equal sign, we cross multiply. So which going to be 4 multiplied by 3.
Paloma.
Yeah?
Look at what it is that you have. Okay, let me put the lines in and go again. Let me put the lines in. Once you have two fractions separated by an equal sign, you are correct. You cross multiply. So now that they are in, tell me how it is I'm doing a cross multiplication. What do I do now?
So the numerator is multiplying the denominator of the first equation.
So tell me what to write. You're correct. So tell me what to write.
That's what I'm gonna say. So at the top where we have 2 plus 2, it is being multiplied by 3.
We have y plus 2.
Y plus 2, Salome.
Y plus son of 2.
You said 2 plus 2.
Jesus Christ, my grandmother. Oh God.
Come. Y plus 2 times 3 equals what, Paloma?
So 3 bracket y. So 3y plus
we have it.
And 3
3y what?
2 6. 3
but
3y6.
What the other side then? What the other side be?
What the other side say? Well, no class. I'm going out the road for see. Well, and you know, I get confused. You see me the district. Sir, then me I go cross multiply the 2 minus 2, which going, but that I go 0. Multiply by 4, that a 0.
Paloma is x, Paloma, not 2. Why you keep on saying 2?
X because through the x point at 2.
I saw. It's 4 times x minus 2. Come, Paloma, come finish it up. What is 4 times x?
4 times x is 4x.
What is 4 times negative 2?
Sure, leave me alone. That's going to be negative 8.
What next?
After we do that, sir, me don't remember now.
All right. You've done well. Somebody else want to take on?
I get so confused.
What do we do here now? Pardon me, not revising the stuff, you know, remember we did this the very first class. We went ahead. Remember, we said we want to isolate the 6, we want to isolate the y, mean that we want to keep the y on that. What is this 6 doing to this side, to the 3y? The 6 is doing what? Anybody, somebody. What is the 6 doing to the 3y? Tyrese, what is the 6 doing to the 3y? Morgan?
We need to minus the 6 from both sides, sir.
What were you saying, sir?
All right, so you're minusing 6 on both sides. All right, so we are subtracting the 6 on both sides.
Oh,
All right,
okay,
so
so
having subtracted the 6 on both sides, we're going to be left with 3y equal, what is, it's going to be 4x minus 14. Do you agree with that?
Yes, sir, because -6 minus -8 is -14.
Good job. What's my next step?
You want y by itself, sir, so you divide
Good
both
job.
sides by 3.
I divide throughout by 3. Excellent, eh? So I'm going to be left with y equals 4/3 x minus 14/3. And that's my answer. Looking similar to what it is that we have here. All right. I'm going to press pause 1 minute. We can't stay on this for the whole night tonight. Matter of fact, I'm sure Sir will generate some questions on this so that you guys can have it for reinforcement. But just to say to you that students, you have to revise. We meet only once a week. The semester is very short. This is no July. You have to revise. And when you're revising, what you previously learned, you can't unlearn, or you shouldn't unlearn it. Because if you unlearn it, you're going to be having a problem. You shouldn't unlearn it. All right? All that we have done here is me building on what it is that we've done for the last 2 weeks, thereabout, or 3 weeks, thereabout. All right? Yes, please. Go ahead, sir.
No, I said 2 weeks. I'm very late.
No, don't worry about it. You're fine. You're a good man. So I don't want to unlearn it. Here my other question. There are some of you in the class, as I've said before, that are very quiet. And me know when it's so quiet, what is happening? No learning is taking place. Is there anybody in the class that is struggling with what is happening here? If so, put it in the chat. If you don't want nobody to see your business, put it privately to Mr. Nicholson.
Sir, I
Because
mean,
the plan is...
I wasn't understanding, but we get with all of
Good
this.
job, Jamila. Good job.
Sorry,
Good
it's the
job.
same thing for me. I was kind of mixing up some of the same steps that Paloma was mixing up. But when we went through this, then I had a general understanding, but I was just box shuffling in a few places. As it relates to this topic, that is.
Okay, so again, no. So let me just read. Yes, please. Go ahead.
So I was just saying same for me, sir. I just need to practice more.
Great. Great. So you see, when Paloma was acting upon support and so on, that's why Mr. Nicholson says, no, you're going to finish off the question. Because you see, when one student has a problem in the class and the rest of you sit down quiet and don't say nothing, we've been teaching for quite a while and we know that other students are having the challenge. So that's why I appreciate those 3 or 4 voices that unmuted and said, sir, I was having the same issue with Paloma. I mean, no, many of you, many more was having the issue, right? But just didn't want to unmute. And that is where, this is how learning takes place. I like the honesty, you know, and let us just continue working as hard as we can so we can get this stuff out of the way. All right, there's one last question on it. As I said before, I don't think I can, this is now 7 o'clock. I don't think I can spend, or the pair of us can spend much more time looking at this. Yes, my answers are there, but the working out is not there. And I want you to work out towards these answers. What sir is going to be doing is find more questions, because questions like these are going to come on the exam paper. I'm not asking me, I tell you. So sir is going to find some questions like these so that we can get it before we leave out tonight, so we can have work to do. Since it's just once a week we meet, what I'm going to be doing is looking for a boot of bath. I'm going to be looking for a handout to give to you guys tonight. I'm going to drop it in the chat to give to you tonight. We're going to spend some time and we're going to go through the handout, and then we're going to do 1 or 2 questions before you leave class tonight. In about an hour and a half, we should be able to understand and finish off that topic. So we're going to start and finish that topic tonight. It's really not difficult. And once we finish that, we can make up some good grounds for the other 2 areas mainly that we need to do. All right, so I'm going to give you 5 minutes.
First, that is the topic that we started to look at last week.
No, it's something new. Last week, what we started with last week? Is this we do last week? Another this we do last week? We started something last week? No, man, this we do last week, don't. Yeah, man, this we do last week.
About some midpoint thing and
Yeah, man, this one.
You know, the
Yes,
last
sir.
part
That's how
of
we
the,
started last week.
you know, the last part of the class we did run through something like that.
Yeah, man, I eat this, man, Fitzroy. The midpoint and the equation of the line, I mean, the length of the line and them something there. Yeah, man, I eat this.
Yo, so that way we're going on now.
No, we done this. We done it. It done.
Okay.
Yeah, man. All right, big up on yourself. 5 minutes and then moving on. Start.
So, Sean,
go ahead, please.
Me still, I kind of have a little itch right up there. So, but I going to try and see if I can write on there.
No problem. You know you have the support.
Right.
Just try this, Andrew, and then if you don't get it now, we know where you're having the issue. All right.
All right. We must try number 4.
Number 4, yes, sir.
Okay, cool.
Sorry, pause the screen sharing and also not seeing the screen.
Yeah, no, I was doing something here. Sorry. You've seen it now, right?
Yes, sir. Yes, sir.
Good job. Good job.
Is this alone working out and then we're going to put it on a graph paper or just this alone?
Yeah, we're not. I don't know what the exam will ask you to do, but I for sure, Mr. Nicholson, for sure tonight, we'll be asking you to put this on a graph paper. The graph paper question will come. I was going to move into the graphs tonight, but I don't think I should because, you know, based on the system challenge, so to speak, Mr. Nicholson and I will work out something for next class around. So I will rather do something that is a little, you know, less tedious, which is what we're going to do next. All right, so let's work and finish off this one so we can move on.
Sir.
Yes, go ahead.
All right. So it's just two things we need to find in this question, right? The gradient and the midpoint.
Just no. No,
So when
first you have to find the gradient.
Gradient of a perpendicular.
Gradient and the right.
Of the line perpendicular. So when you have a
And then the equation. And then the equation.
Determine the equation.
All right. Okay, first you have to find the gradient. Have you found that?
Yes, but my gradient is in negative.
And it's negative 2/3?
Yes.
Okay, how did you find that?
I didn't reduce it down because I have -6 divided by -4.
-6 divided
You should
by.
have ended up with 2/3 because it can broken down. I did a simplify. That's what I was saying.
Okay, so you're finding the gradient of. You're finding the gradient of the line AB, right? That's what you're finding. That's what you just found.
Mm-hmm. Yes, sir. But then to find the mid, I do the midpoint, but no. I'm waiting for you. When you come.
Yes.
I'm waiting on you.
Okay, and then you need
with
to find
everybody else
as well. But not.
Yes, sir.
You have found the midpoint. No.
Yes.
What the question is asking you to do, you calculate the gradient. You have done that.
Yes, sir.
Now you're going to find the equation of the perpendicular line that passes through the midpoint of AB. So what's the gradient of the perpendicular line? If you have found the gradient of AB,
yes,
you need to find the gradient of the perpendicular line, right?
Right. But what I was asking, given that it's a minus, it's a negative 3 over, well, I had -6 over -4, right? And the gradient must be an inverse, negative inverse.
And that's the gradient
I would just flip it and maintain the fact that it's already negative.
Hold on, I missed the grade. What did you find the gradient of AB to be? Gradient of AB is, tell me how you found that.
I use Y2 because I get two some points. I use Y2 minus Y1 divided by X2 take away X1 equal M.
Right.
And I use the points -1 and -5 as my points.
-6, yes.
And 3 and -7 -7. 3 -7. Which give me the -6 over -4, which will simplify to -3/2.
No, it wouldn't. You have -6.
Let me go calculator.
You have negative, hold on. You have -6 divided by?
-4. I divided the -4 by 2. One give me -2. If I divide the -6 by 3, going to give me -3.
Remember saying negative, I cancel negative, you know. So when you cancel out, remember if you cancel the negative sign in too.
Thank you. Thank you. Both signs are the same, so your result will be positive. If you divide negative by negative, if you divide a negative by a negative, you're going to get a positive.
So I should have a positive 3/2.
Right, that's a gradient of AB. And so now you have the gradient of AB. you need the gradient of the perpendicular line. And what's the gradient of the perpendicular?
You're gonna
2
reciprocate.
over 3.
I
What's the
remember say
particular?
The inverse, the negative
inverse.
inverse.
You put the
And
negative
you
sign.
have the
Negative 2 over 3.
there you go. All right. So now you have the gradient, and you need the point that this passes through. Yes.
Mm-hmm.
You need to find the midpoint of AB. And what's the midpoint? What's the equation for the midpoint?
We'll use x1 plus x2 divided by 2
Yes.
plus y1 plus
Not
y2
plus.
divided by 2.
It's x1 plus x2 over 2
Mm-hmm.
and y1 plus y2 over 2. So it would be for the x coordinate, it's what? What's x1? 7?
It's 5.
The x coordinate is the first one in the bracket.
Oh, you mean, okay. All right.
So it's
Sorry.
7
I
plus.
reached to the answer. Sorry.
You reach the answer. Okay, so what's the midpoint?
Okay. 8. That's what I have. Because I use 7 plus 3.
That's
x1.
x1 plus x2. So for the x coordinates, they're different, all right?
Yes.
The
So
point,
I have 7
point
plus 3, right?
is a 0.75, right?
Ah,
And point B is the x coordinate there is 3 and the y coordinate is -1. To find the midpoint for the x coordinate, for the first one in the bracket, the first is it would be what? x1 7 and x would be 3, yes?
yes.
So that would be 7 plus 3, and you want the average of those, or divide that by 2?
Yes.
7
So
plus
get 5.
divided by 2 is?
5.
Okay. And now you want the x, the y.
Yes.
So what are the x, what are the y values? What's
5.
y1?
5 for y1.
Yes.
And minus 1 plus
Negative,
minus 1.
that's 5 minus? 5 minus 1 over 2?
Yes.
And what's that answer? What's 5 minus 1 divided by 2? All divided by 2.
5 plus minus 1. Should I give me 4?
That's correct. And 4 divided by 2?
Going to give me 2.
Correct. So your midpoint is the x coordinate.
7.
No.
So you're not supposed to add them.
You're not supposed to add them. You keep them separate.
So it's just 5 and 2.
X and Y.
I add it up. My Lord.
We separated them, so we keep them separate, right?
Okay.
Right?
Yes, sir.
So your midpoint is?
5, 2.
That is correct. Okay, so you have your midpoint, you have your point that it should pass through, and you have your gradient. So now you need to go ahead and calculate the...
How about see something up on the screen?
Huh?
The answer up on the screen, but never mind. 1 half of my brain are working, sir. Stay with me.
So you have your gradient. And you have your point. Your gradient is -2 over 3. And the point that the line goes through, which you need, is 5, 2.
Yes.
So what equation you're going to use now?
No, I don't know how to do that one there. Hold on there. So if this is x5 and the y at
X is 5 and y is 2. So you're gonna have y minus
I'm not sure.
Y1.
Keep going. Somebody keep going.
Sure, we use the same
Divided
y
by
minus
X
y1.
minus X1.
Yes. Equals?
Equal M.
Yes, and M is?
-2 over 3.
Okay. All right. So you can do you then do your substitution in so it would be what? Y minus
2
y minus 2
over x
divided
minus
by
5
x minus 5, correct?
equal
Equals,
negative 2 over 3.
okay. And then you're gonna do what now? Your cross multiplication, yes?
Yes, sir.
Okay.
When I stop talking, I just decide to write because I hear what you're doing. Don't watch me, just do your thing. Did you get 6 over 4?
Yeah, I got 6 over.
Yes, sir.
We're past there.
Yeah, no, I just decided that I needed to write. I wasn't writing.
Okay.
So we get a 3 over 2, and then now we needed to find the midpoint. How we find the midpoint again? I don't remember. I don't hear you say it. How you find the midpoint again?
Would be x1 x2 over 2 y1 plus y2 over 2, right?
Yep.
What is the x1? Sorry, I wasn't writing. Forgive me. I know you passed here. What is x1 again?
Yeah.
So it would be 7 plus
7 and then x2 is 3. So 7 plus 3 divided by 2.
And then?
Y1 plus y2 divided by 2. So 5 plus negative 1 divided by 2.
So we have this. Do we have the correct gradient? I heard Sir talking to you guys about that. What gradient they asked us to find? The perpendicular gradient.
Yeah, that me I wonder, oh, you have 3 over 2, you know?
No, man. So you're going to flip it and do that. So you get
Okay.
negative 2/3.
Yes,
All right, no. So Sir was talking to you about the last part. Right. Sir was talking to you about the last part. Go on for me, please. I didn't write it. That's why I started writing. Continue, sir.
Yeah, we had gotten to the point where we're finding the equation.
Right. So y minus y1
y minus
over x minus x1.
Yes, sir. Equals to
f.
-2. Yeah.
So which other do I have to use point B or I can use point A? Which one? Or I use the midpoint? Which one?
Sir, I can use a midpoint.
Why?
Sir, because you use the A and B already to find all of these.
No, that's not the reason.
Why? Oh, through the midpoint. Of AB. So that's why we can use the midpoint.
Everybody see that?
Midpoint.
You see that? It passes through the midpoint. So if any of you had used A or B, would have been incorrect because this one here will pass through the midpoint. So we have to use 5, 2. All right, so tell me what to write, please. I know you answer we're discussing it. Tell me what to write. I don't want to tell you. Tell me what to write.
Y minus, so I'm not finishing now. Y minus 2 over x minus 5.
Good job.
Equal negative 2 over 3.
Good job. Excellent. Mateus.
Sir, then you cross multiply now.
Good job. What do I get?
So you have 3 multiplied by y minus 2.
Good job. Next.
Where you're writing, I'm not seeing you.
Then you use the -2, sir.
Multiply by what?
X minus 5.
Excellent job.
Sure.
Go ahead, please. Somebody saying something?
Yeah, I was asking where you're writing. You were writing a while ago?
Yeah. You're not seeing it?
No.
No, sir, not writing.
Well, me know me all right.
The last thing you have, the last thing you have is the y minus 2 divided by x minus 5 is equal to, oh, you stop sharing, sir.
No, you know, well, clearly I may have been kicked out of this other device because it seems very frozen.
Hold on a second. We were at the point where we had, no, I can't even remember the equation.
No, I see this. I see the screen that I was writing on, but I never know it wasn't projected.
What's the last thing you had? Y minus.
Y minus 2 over x
y
minus 2 divided by x
Y
minus
minus
5
y
equal
minus
negative 2 over 3.
Right.
Y minus.
Y minus 2 over x minus 5 is equal to negative 2 over 3.
Yes, sir.
But
Hold on a second, sir.
My system is frozen.
Y minus 2
over x minus 5 is equal to negative 2 over 3. All right, sir is going to share his screen.
Let's see if I can share the screen.
Yeah. I will send this when it comes back up. So this computer is something else. I was saying to myself a while ago, why computer one nice tonight? Boom. Stop.
Sir, I
Right,
work
so
that question and I don't get what you got.
you don't get my answer?
No, sir.
Well, maybe I'm wrong. Yes, please.
So 2x over 3 and minus 16 over 3 is supposed to end up with?
No.
Me no know.
Sir, you know my issue is
All right.
I would remember how to do the individual stages when you are explaining it. But if I'm looking at a question and I'm supposed to take out and follow this, follow that, I start getting confused.
That means you need to practice a little bit more.
So are you guys seeing my screen?
No.
No, sir.
It's dark.
16 over.
I see I'm sharing.
Sir, yours worse than Mr. Chan.
Yours worse than that Mr. Shan.
Let me see if I can bring up the
We
whiteboard.
can see a cursor, a red cursor and a lot of lines.
And a lot of lines. Okay,
Yes,
okay.
sir.
Good if you can see that.
No, it's blank lines we see, it's blank, but we can see remember the old time TV when we have the no
just
signal sign?
say when
Here.
Oh goodness. All right, so
technology giving us a beating today.
Right, anyway, sir, I don't got that answer.
It didn't?
Sir,
All
I
right.
have positive 16 over 3.
That is what I got.
Yeah, y equal negative 2x over 3 plus 16
plus
over
16
3.
over 3, sir. That's what I got.
3.
5
but
who's
remember,
10.
they never reached that part.
It's supposed to be 16 over 3.
Okay.
Yeah.
And so negative 2 as well.
Multiplication, they never reach.
Yeah, negative 2x.
Yeah, the negative 2 over 3 is correct. It's also 16 over 3 that is not correct. I have 10 over 3. It's supposed to be 16 over 3.
Sorry, sir, should it be negative 2x over negative 2 over 3x?
It is. What I have on paper is negative 2 over 3x.
Sir, Mr. You have 2 over 3x plus 10 over 3.
The negative sign is in front of it. Look again.
Oh, sir, I can't see on fire screen, but me just know so you're in the wrong.
No, man. Remember, you have this document.
Sir, at 5 times I do this now. And then I decide to make a tell you say your answer wrong. Because I can't 5 times I do it and it wrong.
You have this document. Remember, I gave you this document last class.
I remember.
So look at
last class.
But look at question 4. The minus sign is actually in front of it, in front of the fraction. So that's another way of writing.
Yes, sir. I've seen it.
Good. So the first part is correct. It's just that instead of 10 over 16, 10 over 3 is supposed to be 16 over 3.
Okay, sir.
Yeah.
What's happening here?
Well, Mr. Nicholson, like him in a worse off situation than me.
I can't seem to get this thing going.
Yeah.
You're no computer crash out like my brain.
The two we don't make one equal.
The 10 over 3 make it.
You didn't get the 10 over 3? No, man. It's supposed to be because that is going to be -6. I'm going to add it to both sides, going to get +6. And then -2 times 5 is going to be -10, +10. And 10 plus 6 is 16.
16, yeah.
All right, just hold on 1 minute, guys. One of us won't soon come up.
And 3y.
This system just shut off. So I mean, no little warning. My goodness. Ah, gosh, computer. You embarrass me, man. All right, let me see if I can.
The screen. And let me just try again. Share. This is blank. Advanced. The crow, man. You. You guys can see the board now?
Yes, sir.
Sir.
Yes.
-2/3. We did a cross multiplication, like you said, like you suggested.
Yes,
So
sir. So it's 3 and the y -2.
Oy. Y -2 equals, forget that long line formula, please.
-2, sir, and x -5.
X -5. That's gonna give you 3 times y, 3 times y.
3y
-6
equals to -2x.
-2x. -2 times -5.
+10.
+10. +10.
Oh, geez. This thing freezing on me again. It just froze on me.
Sir, I think I understand why me get the 10
Okay,
over
so there's a
3 now.
+10 there. So if we to get rid of the negative 6, what we have to do on the left-hand side? We have to add 6, right?
Yes, sir.
Yes, sir.
So if we have 3y minus 6, if you add 6, you have to do the same to the right-hand side. Negative 2x plus 10 plus 6, yes?
Yeah.
Yes,
So
sir.
that's going to give you, oh boy. That's going to give you what? This is gonna
3y
3y
is
equal
to
-2.
negative 2x
Yes, sir. Plus 16.
plus 16.
16.
And
then
again,
you
you only
divide,
want y, so you have to do what?
throughout by 3.
You have to
Isolate
divide
it,
by
those
3,
are
right?
3,
Yes,
yeah.
sir.
3y divided by 3 equal negative 2x
Divided by 3 is equal to negative
2x divided by 3
3
plus
plus
16 divided by 3.
16 divided by 3.
Mhm.
So that's going to give you y
We
equal
cancel 3. Mhm.
negative 2x
Divided by 3
divided by 3
plus
plus
16 over 3.
16 over 3. That's your answer?
Yes, sir.
Yes, sir.
Sir,
Okay.
initially I got the answer that sir got at first with the 10 over 3.
Or the 10. I think he didn't bring over the 6, the negative 6.
Sir, and not only that, what I think I did wrong. So the midpoint that we have as 5 and 2.
Uh-huh.
Remember that we are using y minus y1 over x minus x1
Yes.
equal to the gradient, which is negative 2 over 3. I use my y1 as 5 and my x1 as 2, which caused me to have y minus 5 over x minus 2 instead of y minus 2 over x minus 5.
Okay.
If you understand what I mean.
Yeah, you
So
switch the
that then led me, when I went through the
coordinates.
equation, I ended up with the y equal to 2x, the negative 2x over 3 minus 10 over 3. Because when we reach to this point right here, I wasn't able to do the 10 plus 6 because I didn't have that there.
You didn't have a 6.
No, well, I didn't have a 10. I had a 4.
4 plus, I say 4
Yeah,
plus
because
6.
I would have multiplied the negative 2 by the x, which would give me negative 2x minus negative 4. So when I brought over the 6, I didn't have a 10. If you understand what I mean.
Yeah, man, because you had x minus 2.
Yes, sir. But I
You
don't.
have negative 2x plus 4.
Right, sir. Essentially.
Yeah.
Sir, so how do I decide so in this case where we had the midpoint being 5 and 2, how would I decide which one I use as the y1 versus which one I use as the x1, being that was my mistake in this case?
Okay. All right. Let me just see. I don't know how to use this whiteboard because I always use another screen. All right. So you have your midpoint. It's so hard to write on your midpoint. Or your point was 5, 2. It requires you to write slow. So your midpoint was 5, 2. Yes? 5 is what is the 5? 5 is the x coordinate or x1. Yes? And your 2 would be your y coordinate when you're finding the line. So your x minus x1, y minus y1.
Yes, sir. I understand now. So basically, what happened a while ago is that basically the basics beat me. Meaning
Oh, the X and the
yeah, I was overthinking the whole process.
yeah, man. All right, these things happen Friday evening and you're under pressure, right?
Yes, sir. I'd rather to be somewhere having a drink.
Well, you can have a drink where you are. Water is a, you know. Have some water. A good drink.
Not the one with any other whites in it, please. Tina, see you're unmuted. All right.
All right. So everybody okay with this? Back over to Mr. Shah.
I don't know if this can help Fitzroy as well. When I am doing it, I always try to think of a graph to see what point I will do first on the graph, and I'm always looking to go on the x-axis first. So maybe that's the reason why I always get the x before the y.
Yeah, rightfully so. And that's why I said it a while ago that these is like the basics that beat me just now, because whenever you're plotting a graph, as I know and some other persons know, is that you would normally look to your x-axis first.
Right.
So
You walk
I was just overthinking.
Walk before you jump.
Yes, basically. So,
Walk before you jump. So you go across before you go up.
yes, sir. So that's the
Okay. Always remember that with your graphs. Walk before you jump. Just like in life, yes? X first and then Y. So we all clear on this? I'm not hearing anyone.
Yes, sir, I'm clear.
All right.
Okay.
There are some students. There are some students, Sir Nicholson, that continue to remain silent. I'm not seeing. I've never heard from Tyrese in a class. I've never heard from Shamara. Can't recall hearing from you in a class. I've never heard from Maurice Fletcher in a class. Maurice, you spoke last class. Kimberly Crossley, you did talk one time in a class. You said something, but me need to hear more.
talk.
No, man, me want to hear more from you. Kerry Berry always a talk. Yeah, but there are some of you in the class that, you know, what I'm a little worried about is we're going to finish this stuff and you are going to be found wanting, and then you're going to say you can't learn online and the whole stuff. Me want you to talk to us. You have two of us. Once it was one, now you have two. Talk to us. Talk to us. You know, so we can know, so we can see how best we can meet. Because what is it now? It's now 7:39. We'll entertain some questions by 7:45. I want to share a document with you all so we can just have a conversation regarding the document, and we can use the rest of the time because it can be finished tonight. I can, the pair of us can start and finish this topic tonight. So, sir is asking if you have any questions. He's more than willing while I look for this thing to clear up any questions you may have. So please answer him. Any questions?
So this was from the last the question that was on the board before, right?
Yeah, man. So I gave you this from last time, and this is a continuation from what was on my screen. I had to reboot. It's hopefully to be up by 5 minutes time, so I can send something to you, or 4 minutes time. And then what I'll do, I'll send the workout that I have in the chat, so make sure that you can save a copy of it. Hopefully that I don't lose it since the system went down.
Okay, sir.
Yeah, man.
Sir,
How we stay, guys? Yeah, go ahead. Go ahead.
Oh, sir, regarding the recordings, you post it on
Yeah, man.
your YouTube channel, right?
Yeah, man. We posted the YouTube channel, but remember now, I was saying to you last time around that I didn't have a device. So remember, Romain asked me a while ago, and I told him that I only just collected the device today. So I don't want to do any setup, while I'm not my focus is not fully with the setting up process. So as soon as I set up the device here, I will get the recording to you. But yes, the
Okay,
recording
sir.
is going to be in the look at the description, sorry, to find the YouTube channel
Yes, sir,
and the
I
recordings.
found it, but
Oh yeah.
I've been
But it's just that
looking
I
for
don't
the
upload anything.
recording from
Right. I don't.
last week.
Right. So I wouldn't have uploaded anything because remember I told you, and I apologize again for not doing this. Please just understand my situation. My system crashed. Well, you know when it crashed because I had class with you and I couldn't have the class.
Yes,
So
sir.
yeah. So as soon as I say, I collected the tablet. It came this morning. Came back to Jamaica this morning. So I will set it up so I can send off the recordings over the weekend. All right. I'm just trying to, keep the questions coming. I'm trying to log back into Zoom from this system here so that I can find this document and send off to you. I hope I can find a document with the questions and because that would have been on the other system. So, any other questions? How we're feeling so far? Are we okay? We feel like we can angle and triangle this?
Not triangle it, sir. Not for me, but I triangle it. I'm just have to go out while I was just about to ask, but I just realized. So how we get the two when we at the start of the equation, but I realize is the coefficient of y that we used to divide it. So I go and chuckle.
All right, no problem. Sir Nicholson is going to be generating some questions to send off before we leave.
Computer,
Yes, sir.
my computer seems to be behaving worse than yours.
Sir, I don't know. Them computer this semester. Jeez, please.
This Windows thing that I have to be using. By next week, I'll get back to my Linux computer. This Windows thing just not working for me. So I'm off sharing now, am I?
I'm not seeing you sharing, no. No, you're still sharing.
How do I stop that? How do I stop it?
Look at the
share, yeah.
Look at the to the left of the share. You should okay. Look to see if you see a red icon hovering somewhere there that says stop share.
No.
I don't know the configuration of yours.
Oh no.
Oh yeah. You have just stop shared. All right. So
good. Yes, sir. You said what
no, I was just saying to them that you're going to be looking for some questions. Run about this area that we're looking at just now, so that they'll have some stuff to do. And I mean, if we can't generate those because of the system now, we can always get those, over the weekend and send off in the group. Yeah, man, and the recordings as well. Yes, man, you're going to get the recordings. Yeah, you don't need to ask about them. I know you're going to get the recordings. It's just the shortfall with the computer issues why I'm not where I'm supposed to be. What am I looking for? That's applied math. I'm supposed to be looking for foundations, really. All right, so the system went. Okay, at the first time, I see you talking to the chatting, but never mind. Understood. Now that you say it, I'm understanding. All right, let's see if the system will give me an auto recovery. Aye, aye, aye. Okay, so while this thing is coming up, it's taking its own little time. Those of you who had promised to complete your payments for the Foundation 3 last month end, did you make good on those payments?
Yes, sir.
All right, so I'm gonna check. Aaron. What was it again? Was it 18? I think it was. There were 18 of you that were cleared, and 56 uncleared ECC, Aaron. Nice. I hope you guys believe me now that if my system, it takes about half an hour to come up because the system is up. I'm trying to connect to Zoom. Zoom is having a whole different conversation of its own. I'm trying to get to Aaron. Maybe that's a problem, and I'm trying to confuse this system.
Chat, where's the chat?
All right, so it is important, students, please, very, very important that we formalize the payment for the summer semester.
All right, can I just jump in here, Mr. Shand, if you don't mind?
No, go right ahead, sir. Go right ahead.
All right, I've just put a question in the chat for those who have already completed this one to just have a look at. So it says,
Yes,
find the equation of a line passing through -2, 3, and having a slope of -1.
Which one of the chat? I'm not seeing it. Oh, okay.
Oh, it just come.
Oh boy. Not only am I having problems, I'm also having problems with the internet.
Wow. Yeah, my internet is just it's going around. It's all right. Based on what I'm seeing, students, I had 18 of you. That were so unregistered. I had 18 of you that were registered. That means 18 and 7, that's 25. So it's only 7 students that have cleared their registration fully. Because based on what I'm seeing, I'm seeing only 25 of you clearing your registration. Williamson, Williams, Wilkins, Walker, Taylor, Smith, Scott, Morgan, Mills, Miller, Lindsay, Lihue, Johnson, Innswood, Henderson, Grant, Gillespie, Fletcher, Fisher, Daly, Crossley, Browns, Hans, Brackett, Ashman. And the rest of you, please.
Sir, so I don't hear Lee.
Sir, did you call my name?
Sir, but no, I'm not hear Lee.
What kind of Lee?
Alvry Lee.
Avery, you know,
Yes, sir.
You know, so me not have you. Oh Lord, how this going now? I have you on the unregistered side, Avery.
Sir, you must be mad.
And a me,
Sir, you must mad.
Sir,
Sir,
look for
did you
Tracy
call
and
my name,
Williams.
sir? Did you call
Andrew,
my
I,
hands?
sir, let me not bombard you and just deal with exit Monday morning in regards to that.
Yes,
please.
Alvin.
Okay, sir.
So
Don't
let me
shoot.
tell you. Yeah, I'm only being a bear right now. Let me just look at this thing before I give. But it's important those students that it says unregistered students 48. Let me tell you the names that I have there. And sometimes some things happen. So I'm gonna call the names of those unregistered students. And if your name is called, it's not me. I am not mad, Avery. I'm just being a bearer of what it is that I'm seeing here. So Anderson, Beckles, Bernard, Brooks, Brown, Campbell, Chin, Daniels, Davids, Dawkins Green, Ellis, Fagan, Fox, Francis, Griffiths, Hall, Harris, Henry Smith, Hibbert.
Hold on, sir. Hold on there. You said Harris.
Yes, Andrew. I don't know why them have you already said it, but just give them a call on Monday from there, please.
Sorry, see why I'm saying that I go continue, just I go give extra call on Monday.
You know what I need to do? I need to touch base with them from now and just make because I see Andrew a while ago, Andrew's going, excuse me, did you see Harris? Yeah, man, Andrew, I get Brinkley, no, but yeah, I'm just telling you what I'm seeing. I'm seeing Hibbert, Johnson, Lampard, Lawrence, Lee, Lindsay, Malcolm, Markland, Maxwell, McBean, McIntosh, Murdoch, Parkinson, Pink, Powell, Reed, Robinson, Hammond, Saunders, Tyreek, Simpson, Michael. What me never see that person come in class yet? Smith, Thomas, Tomlinson, Whitaker, White, Williams again. All right. So let me send
Which Williams, sir? Which one?
Quasia and Tracy Ann.
All right, sir.
All right. So which Williams are you?
Tracy Ann. But I'll call them.
No, it's all right. So that means it's three of us. So let me just send a message and tell them, say, yo, no ramp them pitney, you know, because like good students and pay them school fee.
The Africa talking and chat to, sir.
So Africa too? All right.
Sir, Matt being happy.
Hold on. What's our research? So this is part of what it is that we have to do here. So we have to talk about these things in class. So give me the last names, please, of those who are so not last name. So Tracy and TRACYANN Williams. Who else? Andrew Henry.
Bean.
Harris.
Wait, name Andrew Harris or Henry?
Harris.
Oh, Harris. HARIS. Who? Matt Bean. What kind of Matt Bean are you?
Aniki.
Aniki. ANNEKIE. Matt BEAN. All right. Who else?
Oh, sir, I asked, I think Africa and Shamar both asking which Smith it is that you're referring to.
Oh, Smith is Africa. She said one, yes. So AFRIEKA Smith. And who else again? Senior Avery Lee. Avery ALV.
Somebody, can you write my name first?
Somebody said Hall?
Yes, sir.
What kind of Hall are you again, please?
Christina.
Oh, Christina Hall, right. Yeah, I know saying to you that I wasn't hearing you.
But sir,
Anybody else? Yes, please.
Sir, You
Yes,
know
Mama.
that the school need to address this issue though every term since this is my third term, and every term they're doing things like this. Now you have to be doing this, like giving us this information, trying to assist us while it's not fixing the problem. They need to get to the matter of the problem, which is within those offices. Persons are not being what you call productive. If the people now be productive and not complying, you fire them and get somebody else. Replace them. This is foolishness. Because we work and we have to take time off work. Some people lose them salary when they have to go up there because they don't answer phone either. Or when they do, it takes you forever to get through. So they need to address this matter within. It's an organizational thing, and whoever is in charge need to, do some training or something. But it can't continue like this, sir.
I agree with you, and I'm not going to find any excuse. Yes, you would all know that this is my place of work, because when I
I have a
catch,
question when you finish.
yeah, man, sure. When I catch meetings, they will tell you how I speak on behalf of the students, because I mean, I can tell you when the when the system is closed out, I'm in the class alone because my students are affected, and some of the students that are affected are the ones who paid. So I have made my point.
Exactly.
I have made my point. So I am going to tell you that what I'm saying to you, my exec members already know. I am livid about it. You don't play with students. I can tell you, point of information. I did some transaction recently with my alma mater that I have left many years ago. All right, many years ago, way over a decade ago, and I and the people them said to me, "Some owe them money," and I became livid, and even though I had the money with me to just clear my name, I said no, but you know, and I went and I fought it, and I said, look at the system, and I you know went to the department, and the department said, but Sir Shan, look how long you leave here. I said, but me not even didn't know say you still at work here, and they say, Mr. Shan, hold on there, and give me ID number. And they ran something, and she print off something. I said, see here, this is how much you owe. I said, but this is zero. She said, that's the point. There is no way you could graduate from the university and owe them. So it took me years to get this thing sorted out. The amount of threatening letters them sent to me about them going to send me go bureau and so forth and so. My good name, You understand? So I'm saying to you, what's the point? It's not only XZ. I'm not finding an excuse for XZ. It happens with the great UII, and I guess it happens with other institutions. But yes,
Sir, we
Excel
know
needs
that.
to fix
We
the
know that,
system.
sir. But
Yeah,
we
man.
are here at Excel, so our grievances is with Excel. While we know it's everywhere, right now, this is
Mhm.
where we are at, and this is where we would
Fair
want
enough.
it to be addressed. Understand?
Fair
And
enough.
also, it
Happens
is
on
very
a large scale
discouraging for
here.
us to continue. It is very discouraging. We know everywhere have problem, but sometimes if you keep talking, and you're having meetings and we voice our grievances and nothing is being done, it
And that
does
part is
fall,
true.
persons are
Paloma,
going to
you
get
are right there.
discouraged and
Yeah,
don't want to continue.
and you are correct, because I sit into those town hall meetings, and I hear what it is that the students are saying, and yeah, you are correct. You have
And that is why I
such
don't
a
vote for no student, whoever, because them can't do nothing and they won't do nothing. Because if we're talking to the persons who we think have the authority to do something and it is falling on deaf ears, it don't make no sense what you're going to go there and do for us. Nothing.
fair enough. All right, so I sent a message, and
Sure.
I I am also following up with a telephone call, so I can hopefully I can get some information to you guys tonight. You know, this becomes my responsibility as or I should say our responsibility as teachers, to just get you guys to let you know what we are seeing on the system.
Sure.
Yes, sir. Go ahead.
Just before I already say something. This is in relation to the financial clearance, right?
Yes, sir.
Okay, please add my name to that list, sir.
And who is this? Fitzroy?
Yes, sir. I went up there last week, I believe. It's either last week or the week before. Went to finance and
Is it wrong?
spoke to the. Yes, sir.
Okay.
Went to finance and spoke to the lady, and she said everything is good. So I'm somewhat surprised to see this.
Yeah. Yes, please. Go ahead. I'm actually looking for the document as we speak. So continue talking to me until I find it. Go ahead. Somebody said, sir.
Yeah, man, Andrew.
Ahead, Andrew.
I must register my disgust as well to say that I'm one of those struggling students, as you would know. And then now to add insult to my injury. My name is being called on a platform with over 40 how many persons?
Don't look at it like that, because it's when you do it like that, they say, you see, Mr. Sean is the one who come load me up, you know. No, don't look at it like that.
No, but it shouldn't happen.
No, but hold on. But what I'm
Because
saying,
my thing settled so long ago, long time.
And guess what? Remember now, what we're discussing in this setting, you know, Andrew, it's a family setting, you know, because in any event, had I been in a face-to-face class, I would have had a list, and what I would have said to students, okay, the following students, please visit students finance, and I would have come in and I say, Andrew, Alfred, this, and then after that, no, everybody still gonna know says that, so I can't. It would be counterproductive for me to go and email you.
I don't think we're blaming you, you know. It's
No,
just
we're not blaming you.
it's not a blame. You're just doing. You have to carry out this directive in order to ensure that all of your pupils are ready and to you know in line to do their exams and so on and so forth, which we appreciate. However, I can also understand where Mr. Harris is coming from. This shouldn't have happened, especially to persons who, a matter of fact, the school have all of us email. So they need to be more proactive. They can send an email to all the individuals who they presume to have some outstanding funds or something like of that nature.
One minute, Palome, don't go no further. Let me just direct that point before, and I'll give you a chance to finish off. So that point is a point that I raised at some meeting some time ago, and what was said to me in that meeting is that some students don't activate their email addresses. So when the emails are sent, the students are not seeing it. I'm not saying you are one of them. I'm just telling you what is told to us in the meeting when I read.
Oh, them know that. Sorry, nothing no go so.
No, sir, but if you owe them are gonna lock your email. So how we are gonna see their email if they lock with email and change your password?
Oh, Jesus. All right, guess what? You know what is going to happen now? I shall move on with what is
Sir,
happening
Miss
here.
Anderson have her hand raised, sir.
Sorry, I didn't see that. Go ahead, Miss Anderson. Who is Anderson, by the way? Go ahead, Anderson. What's your first name?
Tessin.
Okay, Tessin. Go ahead for me, please, love. Go ahead for me, please.
We're not hearing you. We're not hearing you,
I think she
Mister.
said I might not working. She texts in the chat. Sir, how much is to be paid for this course? Please, can someone ask him for me? Might not working.
I'm not sure. You can ask somebody. What I try not to do is to give
It's
students.
$14,000, sir.
Okay, well, somebody can tell her that. I won't repeat it because I don't want anybody to say Mr. Shan told me is this and then it's not that. So I'm guarding myself on that one. So your classmates would have responded just now. I can't verify whether or not that is the final amount, but the rest of you, I hear from those who are squealing, you know, saying that, boy, sir, this is injustice. My name shouldn't have been on that side of the fence. The rest of you, though, who this conversation really is addressing, please ensure that you did say to me the end of the month, and I wrote an email and told them that my students have promised that by the end of the month, and we just need to do what it is that we need to do. And I know it's rough, but we need to fulfill our financial obligations to the institution. All right, so the document finally opens up, and so this one says transformational geometry. All right, let me see if I can find other one that is the transformational geometry rules is the one. Stone. I am out of Zoom on the other device. All right.
Yeah, before we
all right.
Anybody work out that question that I put in the
Right. All right, sir. I give you a chance, sir, to just finish that last question so I can sort out myself with. All right. So, sir, just go through that last question, please. And then I'm gonna send a question and 2 past paper stuff. I mean, some rules and 2 past paper questions for them to do. All right. So sir, take over. Do that solution for me, please. Transformational geometry. Transformational geometry. Guys, were you able to do that question?
Find the equation of a line passing through the point -2, 3 and having a slope of -1.
Where the question is, sir?
The chat.
In the chat.
In the chat. All right, cool.
It says find the equation of a line passing through -2, 3 and having a slope of -1.
All right. And then now, when you're finished with that one, and please, so hurry up that. I'll give you no more than 5 minutes to do that one so you can go through. And then at least what we really want to do today is to go through these rules, the transformational geometry rules. If we don't get a chance to look at the 2 questions that 2 past paper questions that I've embedded in the document, it's not a problem. As long as we can go through the rules tonight, I think we would have accomplished a lot because we could then ask you to do these questions. The solutions are there, 2018 past paper and the 2017 past paper. All right, so I have those 2. All right, so please hurry up. 5 minutes, and then sir will take that one, and then I'll just go through this one quickly, and we'll call it an evening.
Okay.
Everybody see the question?
Yes, well, I'm seeing it.
Start.
Sorry, say that again, please.
I am seeing it.
Oh yeah, man, that's fine. But just do the question that Sir Nicholson had posted in the chat, and then we'll go through the transformational geometry after. I don't want to share yet. I'm trying to sort out your stuff now, right? So go on do the stuff.
All right. Ready to go? So who's gonna start talking to me now? So you see, you all see my screen, yes?
Yeah, I see it, sir, but
Sir.
I can't help it right now. I'm not so bright yet, but I'm still trying to work on it.
sir.
You're going. Okay. You have
try.
started something. All right. 5 minutes and show me.
All right.
All right, cool. All right, guys. While you work, just lend me an ear, please. I touched base with finance just now, and well, one of the students beat me to it because we were having a WhatsApp conversation while I was having a voice conversation. And Andrew, just one quick question for you. Did you select all your summer courses already? Have you?
Yes, but that's why I want to speak to you after the class, because I'm been embarrassed twice for this week with Exed, because I was called and told that I must drop this course because I did not pass when they told me that I passed, and so it's all embarrassment for me this week. And then this just put the icing on the cake now.
No, but guess what? You know, no way of going because you're gonna do my foundation 3 because you're only self. So don't worry about it. These things happen. All right. Yeah, me hear you. Me hear you. But in life, we will come against some stuff. My colleague, I sent her the names 1, 2, 3, 4, 5, 6, and then Fitzroy says to add his name to it. So 7 names, and I am being asked to. Okay. I'm being asked to just affix the ID numbers to those names. So that's what I'm doing now. So just continue working the question for Mr. Nicholson for me. I'm just affixing the ID numbers to this and send it off. And my colleague has promised that as soon as they get home, they will look at the system and make the necessary adjustments. But yes, Andrew, you and I can have a conversation. Not that I don't want to talk to you, but I'm just saying to you. And then we need to talk about the course that last statement you made. Maybe you can talk off here about it. All right. Continue working on the question, please, guys. And then we're going to switch to, I want to go through all the rules for the document that I just sent.
What? Who's drawing lines all over my screen?
Sir?
Yes, please.
Who's drawing lines all over my screen?
May I go ask you?
I saw them going here, Mr. Nicholson. That them to be the first week.
Africa.
Africa.
Work it out, man. Africa.
Africa is a culprit.
Sir, I get y equal minus x plus 1.
I got that as well.
Okay.
Yeah,
Great.
same.
Everybody got that?
Next week, I'm not class,
Yes,
remember
sir.
that, Yep. Please send the question.
Don't say that.
Follow me.
I
Stop.
have to practice it through, but sure.
Africa, we're gonna stop drawing lines all over my screen.
You see, Africa has children, and if Africa children are gonna do this, why? I bet me beat you. Why you do something at the teacher class and not pay attention? But no, she won't write on our screen. This is what life is.
She not master it yet, man. Try work it out on the screen. I'm just assuming.
Africa, you're writing on your screen. Maybe you can share your screen with us.
Sir, I got negative 2x.
Negative 2.
Mm-hmm.
Negative 2x. Now, man. All right. So shall we go then? Oh,
Yes, sir.
All right. So what's the equation you use? Somebody
Y minus y1.
Y minus y1
divided by x minus x plus 1
Y minus
equal
y1
m.
divided by
X minus x1 equal m.
Equal m.
all right. And from the question I just wrote it up there that x1, y1 is negative 2, 3, and m is negative 1. So just substitute now, yes? So we have what? Y minus
3.
3
okay.
over x minus 2.
Equals to what's
Negative
m?
1.
Negative 1.
Negative 1.
Mm-hmm.
To get that. Okay, so what do we do now?
Cross multiply.
Mm-hmm. All right.
But we won't have one cross multiplication, sir.
To put it over 1.
You put to create a fraction.
Sir, say, really? Sir,
Okay.
I just put y minus 3 equal to negative, yeah.
X plus 2?
Yes, sir.
Yes, sir.
And negative 1 can be written as?
Negative
1 over 1.
1.
So when you do your cross multiplication, you're going to get what?
1y.
1 times
Y
Y
minus
minus 3
equal negative 1 times
plus 2.
X plus 2. That's going to be equal to negative 3 equal negative 1x.
negative 1 times x, same as negative x. You don't remember when you have 1x, you just put x, right?
Mm-hmm. Negative 2. Yes, sir.
So where do I go from here? Come.
So y equal
Mm-hmm.
negative x. Oh, sorry. Let's skip one.
All right, negative x minus
2 plus 3.
Plus 3.
Mm-hmm. Y is equal to negative x
Negative
minus
x
1. What am I talking
plus
about?
1, sir.
It's plus 1, yes. Oh, that's where I get the foolishness. Plus 1.
Okay. That was just a warm-up exercise, all right?
Yes, sir.
Great job. Over to you, sir.
All right, thank you, sir. All right, let me see if can you stop sharing for me, please, sir?
I just did, I think.
Or maybe there's a delay. And I still see your cursor moving.
What is happening here? Aniki, what you doing? Africa.
There's not Africa this time, you know. The thing came up a while ago. All right. Yeah.
How's that?
Yeah, man, you're good now.
Okay.
So,
all right, sir, back to you.
Yeah, man. It's just that the so quick about it, say it wasn't you.
What's that, sir?
You know, somebody borrowed it. It wasn't me. All right. Let me know if you're seeing my screen, guys, please.
Yes, sir.
All right, so we're going to be looking at some transformational geometry. Now, though I have the matrix method beneath the reflection in the x-axis and the reflection in the y-axis, we're not necessarily going to be looking at the matrix method. We're going to be looking mainly at the coordinate geometry method. We're going to be looking at the coordinate geometry method and not the matrix method. So the coordinate geometry is the top one, and the matrix method is at the bottom. All right? So I want you to work with me. This is the easy part because there's no writing that I'll be doing on the board. It's just a conversation that we need to try to use to concretize the concepts. It says a reflection in the x-axis. I think Africa said, I hope I'm correct, said that, sir, when I'm doing these questions, I often think about the graph paper and then just know that again, put in my x first and then whatever the situation is. When you look at the coordinates, you recognize that it says x, y. You walk first before you jump. When you're saying your ABCs, you get to x first and then y after. So when you have your coordinates, as I demonstrated to you at the top of our summer program, that when you look at your coordinates, the x value is written first, comma, followed by the y value. X value, comma, the y value. Those points, coordinates, can be plotted in a Cartesian plane, similar to how you are going to find Excelsior Community College. The location of Excelsior at a nearest point would be Deanery Road and Mountain View Avenue. It is not a exact location for the entrance to the main gate, but if you can find on the map, or you can find yourself at that intersection, Deanery Road and Mountain View Avenue, there's only one Deanery Road and Mountain View Avenue. And that will give you the general direction where Excelsior Community College is located. That's what we're looking at now. So we're reflecting in the x-axis. So we have a point in the Cartesian plane, x, y, and we need to reflect that point, x, y, in the x-axis. Whichever axis that you're reflecting remains unchanged. Whichever axis you're reflecting in remains unchanged. So your xy, your x, y is going to be mapped onto x, negative y. Can you see that on screen?
Yes, sir.
So whichever axis you're reflecting in is going to remain unchanged. So your reflection in the x-axis you're reflecting in the x-axis. Your xy, your x comma y, will then become your x comma negative y. It's a reflection. Put it this way. Put it this way. Everybody is, well, 9 out of 10 of you, I'm sure, are on TikTok. And when you're on TikTok, you can reverse your camera, because sometimes when you see people doing, they're on the same side or they're on the opposite side, so you can reflect the mirror on within TikTok. Let me ask you a question. Does any one of you know exactly how you look?
No, sir.
Why not?
Well, I do.
I'm seeing myself on, well, reverted, I'd say.
Okay, so,
The right
so
turn.
Africa, yes, because I have a mirror. What are you seeing in the mirror?
Reflection.
Reflection.
In a reflection, but is that a true picture of self?
No.
Yes.
You say yes? Okay.
Yes.
When you raise your right hand, where does it fall in the mirror?
On the
On
left.
the left,
What we said.
reflection.
Okay.
So is it a true picture of self? That's what I'm asking.
No, sir.
No, it's not.
No,
It's a
sir, it's
reflection.
not.
Right. So so there is always a question of mine. Do I actually know what I look like? I have an idea. But do I actually know? I can tell you what you look like. Because I'm seeing you. I can tell you, say, yeah, you have a mole right here. I may have an idea, but I am not seeing me. What I'm seeing in a mirror is really a reflection. Right? So getting back to this, and this is a conversation that we can have further on. You can research it, you can come back to me and say, no, sir, me know exactly how me look because what I'm seeing is really me. Fine. It's a conversation. Let's go. When I am whichever axis I'm reflecting in, that axis remains unchanged, the other one changes. So I am looking at my x-axis, comma my y-axis. Once I'm reflecting in the x-axis, the x value remains unchanged. I'm reflecting in my y-axis. Sir, can you give me an example? Absolutely. We'll see the example shortly after. I want to just make sure that I cover all of these.
Repeat that for us, Sir
Okay,
Sean.
sir? Yes, sir.
Repeat what you just said, sir.
No, I'm just saying that if you are reflecting in the x-axis, the x value remains unchanged, but the y value changes.
Okay.
Right. So I was also saying to them that I have questions embedded in this document that we can look at, but I just want to go through the rules. So just remember, whichever axis you are reflecting in, that axis is going to remain unchanged. So I'm reflecting in the x-axis, my x value is going to be unchanged, right? And of course, similarly, if I'm reflecting in the y-axis, the y value will remain unchanged. If I'm reflecting in the y-axis, reflection in the y-axis, the y value is going to be unchanged. So the x value changes, but the y value don't change. And I will demonstrate that to you in a few. Just try and appreciate what it is that I'm saying. So look at my xy now, my xy value. Yeah, I can use a coordinate geometry method, Africa, or I can use a matrix method. I'm not using a matrix method. I'm not using a matrix method for this. So I'm just using a coordinate geometry. I have another document where I took out the matrix method, but that document don't have the questions attached. And I really want to give you some questions tonight, right? So we're not looking at the matrix method. So the coordinate geometry method is what it is that we're going to be looking at. So your xy, your x comma y will map onto x comma negative y when you are reflecting in the x-axis. How do you know that, sir? Because the x value remains unchanged, but the y value changes. The x value changes, but the y value changes. All right? And one is the reverse of the other or the opposite of the other. All right? So if I reflect in the y-axis, yeah, think about it. The y value will remain unchanged, but the x value is going to change. So my xy is going to be mapped onto my negative x comma y. See here? Negative x comma y. Just remember, whichever axis that I am reflecting in will remain unchanged. Whichever axis I'm reflecting in will remain unchanged. What changes is the other axis, right? So that's 2. When I'm reflecting in the line y equals x, put it this way, x becomes y becomes x. Anywhere you see x, you put the y value. Anywhere you see y, you put the x value. Look at what it says. My xy maps onto y comma x. Can you see that?
Yes, sir.
Because my x now becomes my y, and my y becomes my x. See here? Y equals x, x equals y. Y equals x. Remember, an equal sign is a sign that can be read from both left to right and right to left. So when I reflect in the line y equals x, my x value becomes my y value, and my y value becomes my x value. Then, sir, where do you just change them around? R2. See here? Xy becomes yx. But watch this. I did say something earlier. We're talking about opposites. So reflection in the line y equals negative x. Reflection in the line y equals negative x. Y equals negative x. Remember, now the same thing will happen now. Because y equals negative x. But if I divide both sides by -1, I'm going to have x equals negative y. Then rockstone. Then you're not going to have negative y comma negative x. See it right here, so same difference. So it's the same thing as this, but because one is negative, it makes both of them negative. All right? So, what is that R word? What is the R word? Refreshing what it is that we've learned. When I'm reflecting in the x-axis, my x value remains unchanged, but my y value changes. So when I'm reflecting in the x-axis, my xy moves on to x comma negative y. Guys, these are rules that will not be given in the exam. You must memorize these. And that's why I had that conversation earlier with myself. And you're wondering, sir, we're not hearing you. Because I want to give you this early up. You have enough time to study. There are only 8 of them. And 8 is an even number. And technically, I have 4 pairs. So 4 times 2 is 8. So it's just 4 pairs that you have to work with. So if you learn one, you just reverse it for the other. So it's only 4 times you have to learn the stuff. When I'm reflecting in the x-axis, x value remains unchanged, y value changes. Xy maps onto x comma negative y. When I'm reflecting in the y-axis, the y value remains unchanged. My xy maps onto negative x comma y. Remember, whichever axis you're reflecting in remains unchanged. We're moving on. Reflection in the line y equals x. Think about it. X becomes y becomes x. So xy maps onto y comma x. And then the opposite of that is true. When I reflect in the line y equals negative x, my xy maps onto negative y comma negative x. Tell me in this real life, those 4 things hard to remember, you think?
No, I don't think so, but we have to start now, I guess.
Right, and it will come in practice. All right, let's go. So that's 2 pairs. Reflection through the origin. Now that one is kind of tricky, see? When I'm reflecting something through the origin,
Yes.
When I'm reflecting something through the origin, my xy really becomes negative x comma negative y. You know why? Because I am going through that point that it's the same value, but think about it. I am going in
What direction at the same time?
Think of a graph paper. All right, no, let's go. If you have, I don't know how many of you are in cadet, but if you're standing facing any direction and you are making an about turn is how many degrees?
180.
Okay, everybody agrees?
Yes.
Okay, I agree. When you make that about turn, are you facing in the same direction that you started off with?
Directly opposite.
No, sir.
No,
Sir,
sir,
Mula,
it's
the
the opposite
opposite.
direction.
The opposite.
So that is the best way I can explain the reflection through the origin. So my xy now maps onto negative x comma negative y. You're at the same point, true or false?
True, sir.
Sir, we're just in the
So
opposite
when you make a boat
direction.
turn, if you're in the same cadet, something like I was in, you can you stand up on the same spot, but you just reverse in your position. So so it is sorry?
Go ahead.
So the reflection through the origin is going to be xy maps onto negative y, negative x over negative y. But guess what? There is something that is very similar to this one, because look at what I'm saying. This is going to be the same as 180 degrees rotation about the origin. Because remember, when I reflect through the origin, it's as if I am rotating 180 degrees. Whether that 180 degrees could be a clockwise rotation, 180, or an anti-clockwise rotation. What do I mean by clockwise? Clockwise go from where to where? Clockwise go which way?
Left to right.
Left or right?
Left to right.
Say what now? Clockwise go which way?
12 to 1.
Right, turn right. The right to
Right
left.
to left.
Sir, me say right to left.
Right to left, sir.
That me said to right to left.
So anti-clockwise is when where?
The
Right to
anti,
left.
sir. So the anti or the
Left to
clockwise? Which
right.
So you
one?
said clockwise or
Anti-clockwise.
anti-clockwise,
Clockwise,
sir?
no. So which one you asking?
I first said clockwise, and then I'm hearing an answer that I don't agree with.
Sir, clockwise is to the right.
Duh, I saw me that thing too.
Anti-clockwise are the other way. So,
Yeah. But I think of a graph.
Oh,
Think
can't
of
you say it, sir? I wonder if I wrong. Come here and say wait.
No, it's just I was gonna say think of a graph, but it's not a graph I wanted to say. I wanted to say a clock. No, it's just that somebody was saying something else to me, and oh crap, I can't write on my from the system, I can't write on my PDF file. So I was going to draw a clock. So when you're at a clock and say that you're at 12.
What?
Move from 12 to 3. Which direction am I going? Am I going in a clockwise direction or anti-clockwise direction?
Clockwise.
And what direction is that? Right or left?
Right.
Yeah. And if I go from 12 to 9, which direction am I going?
Left.
Mm-hmm. So therefore, it's an anti-clockwise direction. All right? So you have to remember that. So whether or not I go 180 degrees, turning from left to turning to my left, or I go 180 degrees, turning from my right, it means that I still end up at the same space. Think about it. You're at a point. You're at a particular point. And that point you're turning 180 degrees. If you turn 180 degrees clockwise or anti-clockwise, are you ending up at the same spot?
Yes, you are.
Yes.
Absolutely. So you'll find out that there is a similarity between. Go ahead.
Sir, would it be the same thing as Paloma and I are in the same spot, but my back is facing her front? Would it be something like that? Or no?
Your back, both of your backs are together.
Yes, sir.
Right.
Okay.
So you're standing at the same spot.
Yes, sir.
Both backs are the same, right? So it means now that when you assume Paloma's position, it means that you'd have made a 180 degree either clockwise or anti-clockwise.
Or anti-clockwise, yes, sir.
Right. Or it can also be a reflection through the origin. Fair enough?
Yes, sir.
And then now we have 6, 7. I'm going to touch last, and then I'm going to go to 8 first. You see the same thing I just talked about a while ago? The rotation 180 degrees clockwise or a rotation 180 degrees anti-clockwise is going to be the same thing as a reflection through the origin. XY maps onto negative X, negative Y. So guess what? There are three things that will give you the same result. Either a rotation 180 degrees anti-clockwise, a rotation 180 degrees clockwise, or a reflection through the origin. Fair enough?
Yes.
Yes, sir.
So we have done 6 of the 8 rules. And allow me to go again. When I'm reflecting through the origin, my xy maps onto negative x, negative y. When I'm reflecting through the origin, my xy maps onto negative x, negative y, which is the same thing as a rotation 180 degrees clockwise and a rotation 180 degrees anti-clockwise, where xy maps onto negative x, negative y. Boom! One something kill 3 birds. I may have 8 of them, so I have 5 more to talk about. But look at how I'll catch 4 more. Well, actually, this is 2 in 1. The 180 degree clockwise and anti-clockwise, 2 in 1. Hear me out. When I'm reflecting in my x-axis, the x value remains unchanged, the y value changes. So xy maps onto x, negative y. When I'm reflecting in the y-axis, the y value remains unchanged. So my xy maps onto negative x, y. Whichever axis you are reflecting in, that axis is unchanged. You are standing in that position and you're reflecting, so you're looking at the other one. A reflection in the line y equals x. X becomes y, y becomes x. So xy maps onto yx. And the opposite holds true. When I'm reflecting through the line y equals negative x, xy is going to map onto negative y, negative x. All right? So that's reflection in the x-axis, reflection in the y-axis, reflection in the line y equals x, reflection in the line y equals minus x. We talk about a reflection through the origin. So we have 5 reflections. We've done those 5 reflections. We have 3 rotations. But one of the rotations we know, because a rotation 90 degrees, the rotation 180 degrees, clockwise and anti-clockwise, will give you the same result as a reflection through the origin, where x maps to, right here, so negative x, negative y. All right, finally, this is the one that gives students, or these are the ones that give students a little bit of trouble. And I want to spend a little bit of time on it. Let's hope I can find a way to explain it. It's a rotation of 90 degrees, either in a clockwise direction or an anti-clockwise direction. Now my xy in an anti-clockwise direction goes minus y, x. In an anti-clockwise direction, my xy goes minus y, x. That's a rotation. The rotation goes in an anti-clockwise direction. Please, where the students mix up, the student mix up anti-clockwise with the clockwise rotation, 90 degrees. You can't afford that to happen. So let's go again. So when I'm rotating 90 degrees in an anti-clockwise direction, my xy goes to negative y, x. Now, let me just get something clear out of the bat. We're talking about a rotation. Do you agree that my xy will be rotated because both of them start with y and then x after? Talk truth.
Can you repeat that, sir?
I'm saying to you, we're looking at a 90-degree rotation, both clockwise and anti-clockwise. And I'm saying to you, can you agree that for my clockwise and anti-clockwise rotation, that both of them, the values would have been rotated because instead of having xy, I have y and x, and then y and x. Can you agree with that?
Yes.
Okay. Is only one person seeing it?
Sure.
Yes, sir.
Yes, sir, I see it as well.
Okay, good. The only difference now is which one we have the negative. You remember, you know? Remember, watch me. There is no rotation here. It's just the signs that are different because my direction changes. So XY maps onto X and Y. But it's also the signs that change. In this one, XY, there is a reversal because it's a reflection through the line Y equals X, Y equals minus X. So put it this way. This couldn't be a rotation, but sorry, this says a rotation because X and Y them rotate. So no, if this were to be a rotation, either this can be negative or this one negative. Are you following me?
Yes, sir. Because they're going to go on the opposite side.
All right, good. So if you're seeing Y comma X and none of them have a negative sign, pretty much. And I'll explain what I mean by that. Just take that for what it is. I'll explain that sometime later. My XY becomes Y comma X. It means that it's going to be a reflection in the line Y equals X. If my XY becomes negative X, negative Y comma negative X, it simply means that I'm going to have a reflection in the line Y equals minus X. Watch this now. This can be in a rotation because these are same X and Y. It's just that the direction changes. Watch me now. Look at another Y and X. Oh, sir, I see what you're saying. Had this been in the line Y equals minus X, the one would have been negative 2. And if this was a line Y equals minus X, the one would have been negative. Oh, so you're saying now, sir, that when I have a rotation of 90 degrees, one of them is negative and the other positive. And this positive. All right, I've seen it now, sir. But which one is negative? My anti-clockwise is going to be where my Y is negative. My clockwise. No, put it this way. Put it this way. Put it this way. Haha. Put it this way. Remember, I gave you an exercise just now that when we're looking at a clock, when we go to the right, when we go to the right, so we're moving at 12, we're moving from 12 rather, to 3. Which axis I believe 12 is on?
Can you repeat that, sir? I'm trying to.
Axis is 12 on.
12 is on the Y-axis.
See, like I don't know for each lot, no man. Sure. 12 is on the Y-axis. Which axis is 3 on?
X-axis.
X-axis.
So when I move from 12 to 3, what direction am I going?
Clockwise.
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 Good. See here? I'm moving from 12, where it is positive, and I'm going to my 3. But no, it's going to be a negative X. But sir, why? By convention, positive rotations go anti-clockwise and negative rotation go clockwise. You follow that? By convention, positive rotations go clockwise and negative rotation go clockwise. Rubbishness. Positive rotation go anti-clockwise and negative rotation go clockwise. So if you're moving from 12 to 3, you believe that it's going to be in a clockwise direction. But what is really happening? You're moving from 12 to 3, it's going to be in a 12 to 3, it's going to be in a clockwise position, but that 3 now you're going to rotate this one. So instead of being positive, it's going to be negative because the negative rotation go clockwise. So this is why we have a negative X here. All right.
Sir,
and for my go ahead.
Is it? I'm trying to imagine how it would look on a graph, right? To see. So you know the 12 would be up at the Y, up on the positive side, right?
Very good.
But the 3 is also on the positive side.
Very good. Excellent. So let's read again.
Understand.
You're on the right track. So let's read again. By convention, positive rotations go anti-clockwise. And the negative rotation go clockwise. So you would think that negative will go anti-clockwise and positive will go clockwise. But because you're rotating.
That me I think.
Right. But I'm not so because we're rotating something. So by convention, positive you think are X go clockwise, but it's going to be the opposite. So when you're talking about a rotation, don't think that because it's a positive rotation, it is going to go clockwise. No, it is going to go anti-clockwise. So that's why I put it in bold right here. So so you can understand what it looks like and what it is. So you're seeing it in bold.
I say,
All right?
but you always find a way to become more and more complex.
No, it's not a matter of complexity. It's just that
Oh, and the bad fix, right?
no, it's not a matter of being complex, because I'm sure when you start counting your dollars in billions, and somebody say, "Blow, you have billions," I'm saying, "What you about trillion and then quadrillion?" It's not complex them time there because you're counting big money, right? But the truth of the matter is, there are just rules. You know when you and that's what it is. So positive should go clockwise, but in this rare case, it's different. Just remember that. In this rare case, it's going to be different. What I'm saying to you, there are some rules that we do. When you go a spur tree, let me see if you can drive. When you go a spur tree, oh, you take spur tree hill. Come, Harris, come talk to me. When I go take spur tree hill, or you do it.
You mean in terms of gear rotation?
No, man, in terms of driving, yeah. Or you take it. You drive a standard, or you take it. Africa said gear 2.
Low gear, sir. Second,
Right.
third.
You're using low gear to climb the hill, but you
No, to
also
go.
use it to descend the hill as well.
Mm-hmm. And your foot going hover over the clutch, don't?
Correct, sir.
And if you drive a automatic, you gonna gas it down? Just dead.
But no, you can't guess it. You have to
No,
put it
sir,
in the low gear.
you can't get
Just
it done,
dead.
sir.
Sir,
Just
if
dead.
you hold the brake too long, you just dead either way.
True that, because it go skid. So you have to massage it gently. Yeah, man. You have to touch it and let it go and touch it and let it go. You have to massage it gently. And guess what? I was coming from a road up Constant Spring the other day, but that road is very dangerous. And I tell my family members, when you're driving on that road, don't make nobody toot you for come out. And I went to the road. It's called Hillman. And you take Hillman to go up to Constant Spring Road, up or down Constant Spring Road. But guess what? You see the man them come from Immaculate side, tax office side, for come down on Half a Tree Road. I mean Constant Spring Road. You see when they light upon amber, the man them a shut it because not care when it turn red, them a go through. No, the people them who come from Hillman would see the green and go out and get dead. I have seen several misses, and I said to my family members, yo, when you drive and you're at the top of the line, anybody want to blow you, make them blow you. So here goes 2 weeks ago. I am there at the top of the line. But from before, this man behind me, him a two. Now pay no mind, because if you're impatient, just go over me. And I got to the top of the line. And the light changed, but because I know, I did not move off same time. And the man behind me, toot. It's a bit, by the time I decided to push out, it was a Ace Ace hardware truck. You know, the big Leland truck, them when they cut a pure metal. And that run in front of me. No my little pot when me drive. Me sure say that lift up and skin properly about 100 times in the air before it drop down. I would have been a dead man. It's not really any stoplight, because some stoplights, well, maybe, yes, Romain, but that one in particular, I've seen it happen so many times. So many
Yes, sir,
times.
because where the white line is, it's so far in you can't really see
Absolutely.
what's coming down the road. So a lot of times, yeah, you just have to give
You're
it
right.
some time. Because if you go out
Give it
real,
some time, run off.
so
And
yeah,
you know me
how
do?
does that try beat the amber?
The amber. Yes, I.
Yeah.
So the man a toot, me and so forth and so on. You see, when I went across the light, I turned on an avenue, and he turned on the same avenue with me, and I said, you know what, this is an opportunity to talk to him. So I just fan him down. Yeah, pot. So I fan him down, and him stop. And me say, don't even they go across the light, the man would have picked me up. Him say, for real, man, him brought the light. Me said, that's why you must stop tooting people, because you would have killed me off. Any old me that follow you. Him say, no, a real talk can make me out, a real talk. Me say, stop tooting people, because if I do one young driver and the young driver get nervous, the young driver that go cross, I would have been history right about now. history. So, what's the moral? There are rules that we know say we get the green, we're supposed to go. But we are saying to you, take a delay. We know we are going on a spur tree, and we know say, boy, you know, we can't even take the corner. We can't even hug the curb like we're taking a normal turn. We have to take it like a wideish. And we can't just take it wideish blindly. We have to take it wideish and look to see who will come up. And if you see somebody will come up before you, just cancel back and hold your corners because you know one for go over. So many things happen there. Right? So what I'm saying to you is, yes, we understand that by convention, positive would be clockwise and negative would be anti-clockwise. But in this particular case that we're doing the stuff, it is going to be the reverse. When you see it on graphs, you will understand a little bit more. Make sense?
Trusting you on it.
You're trusting me. All right. All right. I'm happy that you're trusting me. You have 3 minutes, and I'm not going to go over my time. I'm just going to do one question. I'm going to give you the others to work. Here it says, triangle ABC. Nice job. Triangle ABC with vertices boom, bam, and bam is reflected in the y-axis. Calculate the position of the images of ABC. Okay, so you see the original stuff is called your object. You see what you see thereafter is called the image. So when you look in the mirror, you are the object standing in front of the mirror. But what you're seeing in the mirror is going to be called your image. All right? So it says calculate the position of the images of A, B, and C. Now, how do we signify the image of A? The image of A, we're going to call it A prime, one little stroke above A. B, we're going to call it B prime, one stroke above B. And C, we can call it C prime. And if we're talking about a second image, A double prime, B double prime, C double prime. A triple image, A triple prime, B triple prime, C triple prime. All right? So let's go. We said to you that if we're reflecting in the y-axis, the y value remains unchanged, but the x value changes. Talk truth.
Yes, sir.
Yes, sir, because they go on the opposite side.
Right. So tell me what would be A prime if we're reflecting this in the y-axis? What would be A prime?
3 negative 5.
Sir, A that be no negative 3, 5.
Negative 3. Very nice. So not A, but A prime. A prime would be negative 3, 5. What is B prime?
Negative 1, 1.
Very good. C prime?
Negative 4, negative 2.
Pick up itself. Everybody seeing that? The y value remains unchanged.
Y remains same.
Good. So let me just let me just fix up this question and say, what if we were reflecting in the x-axis? What would be A prime?
What will be what, sir?
A prime if we were reflecting in the x-axis.
Sir, the A1 that be 3 and negative 5.
And B prime would be?
1, negative 1.
And C prime?
4. Stop. And B to that be to positive 2 now.
No. Pick up yourself. Pick up your good, clean self, my friend. Nice. All right? So, I have on this the solutions to the question. So you see A prime, when you reflect it in the y-axis, A prime now becomes this, B prime becomes that, C prime becomes that. What you are going to be doing for us in class, between now and next week, Friday, God's willing, what you are going to be doing for us is to go through this document. There are 2 sets of questions. That was 2017 with all the questions and what it is that we did. We'll put those, the answer and the mark scheme in place. And there's another question for 2018, and we give the question, and we're going to go through the stuff. Your responsibility, you have copies of this. Your responsibility is to go through. You see those areas that you're not agreeing with what the answers that Mr. Nicholson and myself have on this, we're going to take it to class next week. And we're going to discuss it. Now, hear what is going to happen for next class, all God's willing. We're going to be spending time. The topic is finished. This topic is finished. The only thing that we now need to do is just do some questions. And I gave it 2 past paper questions, valuing 30 marks each. You can go into the exam and see a question looking like this. But you must know the 8 rules. Them nah give you on paper. You have to know the rules out of your head. But guess what? There are students over the years teaching this course who learn the rules. And every year them get them 30 out of 30 for the question. Every year there is at least one student. Some years they have many students get them 30 out of 30 for the question. All right? So what is important? You're going to go through the rules. There are 8 of them. Reflection in the y-axis, reflection in the x-axis. Reflection in line y equals x, reflection in line y equals minus x. And then you have a 5th reflection through the origin. All right? And then you're going to have a rotation, 90 degrees, 180 degrees clockwise or anti-clockwise, which is the same as the reflection through the origin. And then you're going to have your 90 degrees anti-clockwise rotation and your 90 degrees clockwise rotation, right? In the clockwise rotation, you're going to have y, xy mapping onto y comma minus x, and then it's going to be the opposite for the anti-clockwise rotation, where we have negative y comma positive x. All right. Any questions?
You're going to send it in the chat now, sir?
It was sent.
This.
It was sent.
It was? Sorry, I wasn't hearing that at one point.
Okay.
I got kicked off as well. I don't know if it was just me or what. Could you please resend it?
I'll try just no.
Where did you post that, sir? You posted it in the chat? Session?
Yes, sir. In the chat. I answered it, sir. In the chat.
Okay. It's there. There now. I'm just making sure. Because I'm monitoring the chat.
All right. So it's just resent again. Yeah. That's it. That's it for tonight, guys. How was class? Anybody learn anything?
Sure, relearn again.
Learn about that anti-clockwise because I'm thinking if you're going positive, it should be clockwise. So I learned that.
Right. Very nice. Very nice. Very nice. Anything else? I mean, so we finish off unit 1 now, the coordinate geometry, done. I did this one because, since we're on geometry, we just, continue with a little geometry. So we're looking at the coordinate method in doing this. This topic is also finished. I'm telling you, there's nothing more to this than what it is that we just looked at, right? So it's just for you to answer the questions and to know the rules. Now, hear what is going to happen for me that I want you to do for me. When you're studying the rules, study them in pairs. All right? So you're going to study the reflection on the x-axis, the reflection on the y-axis. And just try and remember that. And when you think you know it, then you can move the reflection of the line y equals x, the reflection of the line y equals minus x. And when you think say you know that, then you can look at the reflection through the origin. And when you done the origin, move directly to the reflection of the rotation of 180 degrees clockwise and anti-clockwise. Because then you'll make a comparison to know that it's the same thing as a reflection through the origin. And then now I want you to look at the rotation, 90 degrees clockwise and anti-clockwise separately. So we have those 1, 2, 3, 4 things to look at. It's 8 of them. Put them in pairs. Trust me, by the weekend is out, I promise you, you will know it. And then come Monday, right back until Thursday, you're going to refresh it. You're taking a dunk, recite it. You're taking a fresh, recite it. You sit down in front of your computer at work and something not happening, just forget about that and just say rotation, reflection, and you get it. I promise you by next week, on a box off them topic here, and we can move on into something else. So we'll spend together maybe the first half of the class to just run through the questions that you have. We'll see if we can find some more past paper questions that we can just post it in the class, and then we'll run through some more of those questions and move into another area. All right? That's it for me. Sir Nicholas, you have anything?
No,
Sir.
not at this. We have a class group or something that I could send.
There's an email group. I'll add you to the email group. What we try to do is We don't do WhatsApp. Well, I'm not a part of the WhatsApp, but what we can do is I'll add it to the WhatsApp, the email chat. And what we do, we send the communication to all, so we have a thread, a continuous thread going. So I'll add it to that, so you can be a part of the communications going across.
Thank you, sir.
Pick up yourself, guys. Have a good one.
Sir
Sorry,
J.
good night, sir.
Sir
Good night,
Shan.
sir. See you next week.
Yeah, man, no problem. Somebody saying Sir Shan. Who's that?
Yeah, man, Andrew. Remember, I want to talk to you for about 2 or 3 minutes.
No problem.
All right.
Drop in on
And
304.
that means I need to get off.
Yeah, man, no problem. Yeah, man. 304.
Sir.
506 7711.
906.
No, 506 7711.
All right, yeah, no problem.
Thank you.
Sure.
All right. Yeah, somebody saying sir again?
Okay, I was asking if it was possible for us to pay like the course money like next week.
The course who?
Like for the course, like next I finish registration. I'm not sure if it's possible.
You're saying that you try and finish off the registration by next week.
Yes, sir.
Come on, please do. Because there's going to come a time where it is that, you know, the institution is going to take their usual decision to do their usual stuff. So I am only taking it to the class to put you on guard that, you know, there are some things that must be done. So sure, please just make sure by next week when I come, I can see it off a list from the unregistered to the registered part. And Miss Lady B from Finance has promised that when she gets home, she's going to look at these for me. All right? Yeah, man, thanks. All the best, guys. Thanks for coming out.
Okay. All right, sir. Talking.
We'll talk. We'll talk.
We'll talk soon, yes.
Cool.
I think I can leave.